Okay. Is it a hump or a drop? What do you say? You've got to twist your words in every which way, because the model will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line, or does it curve? Some people don't clamp it, but that is absurd. We all know that the model dictates what you do. And everybody knows that you've got the model affliction blues. Model affliction, it's your addiction. Model affliction, it brings you so much pain. It's your ball and chain. Conflating curvature with elevation change. Just got your local distance just out of range. That oblique is gonna dictate everything that you do. And everybody knows that you've got the model affliction blues. Model affliction, it's your addiction. Model affliction, it brings you so much pain, and it's your ball and chain. It's your decision defending the model position. You just don't know the geometric proposition. That old ball will always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction, it's your addiction. That old model affliction, it brings you so much pain. It's your ball and chain. And everybody knows that you've got the model affliction blues.
Works really good with this guitar.
Is it a hump or a drop? What do you say? You got to twist your words in every which way. We all know that the model dictates what you do. Well, we know you got it, the model affliction. Model affliction. Model affliction. Model affliction. the model affliction blue.
And we are live. Welcome, everyone. It's Model Affliction Monday. We're on sort of summer holidays at the minute, so I don't know how much we'll be going. We'll do Mondays and Fridays this week, but the rest of the week we will be practicing for the new podcast styley stuff to come next week, I think. So I mean, we'll do that whenever, but as usual, Model Affliction Monday. This is where you get the chance to express your affliction. I mean, if you can't do it, I mean, there was an offer made from a blue marble scientist to simply explain the basics of spherical geometry. But as we've said, and we've had a discussion with a mathematician this weekend, it's entirely Euclidean. So I'm not too sure how he's going to be able to do this. But we're rooting for you and the explanation of spherical geometry within a model, a demonstration, simple demonstration. I'm not so sure it's going to be coming. I think it's like Ranty going up the hill with an auto level. Some things that just won't happen. We've also been this weekend going over I don't know what you call it, a model affliction. Of a guy who's put a series of videos out. He's a bit scared to talk for himself. He's a modern scientist called Icon Science that seem to be afflicted by models. So I don't know what should we go over first. What do you guys, anybody got anything else from the weekend? I've learnt loads this weekend how to approach conversations and stuff. Anyone got anything? Okay. Right, well. Should we go over some comments, some model affliction? Or is anybody really bothered about it?
I mean, it is Model Affliction Monday, so if any day, it would have to be today, right?
Okay, so let's see. We've got. Let me see if I can get this on the screen for you guys, and then we'll get it on the big screen for everyone else. There you go. Right, so this is I think this is from Friday. A bit bigger. Need it a bit bigger than that. I'm not so sure whether. Let's see whether we can. So this is a conversation. Now, this came from, let's see who started it. I don't know, some user unknown. And this is how conversations develop. Yeah, it says something about whatever. I say, I know that horizontals are parallel. All triangles have 180 degrees. Change my mind. And Stefan Mudd, I hope Stefan's watching, because he's going to be one of the star guys of tonight, the YouTube text commenters. He says, you claim that horizontals on Earth are parallel. I think I just said all horizontals are parallel, but all horizontals in reality. And not on the Earth, but like above the Earth and anywhere, really. All horizontals. And then he says, what is the shape of the Earth, if your claim is correct? I mean, I don't know. To make a claim about horizontals, yeah.
Horizontals doesn't change the shape of the Earth.
Yeah. So, I mean,
And the other way around as well.
I'll call that a non sequitur then, right?
Completely, yes.
It says, what triangles do you claim have 180 degree internal angles, planar or spherical? And Kestrel says, have you proved that? I say to Kestrel, yes, triangles having 180 degrees is a proof within mathematics. Yes, you can definitely prove that triangles have 180 degrees. Well known.
Easily done.
And then Stefan Mudd says spherical triangles having an excess of 180 degrees also has a proof in mathematics. Legendre's, Girard's and Gauss-Bonnet theorems of spherical geometry give proof of this. Or do you still deny spherical triangles? Well, this is model affliction, right?
Yep.
So I say, you're saying you believe there's a proof within mathematics that triangles have 180 degrees, and also a proof that triangles have more than 180 degrees. Isn't that contradictory? Me asking him.
Spherical triangles being not triangles, they have excess. So, okay. These figures with curved lines have excess, yes, but they are not triangles. Sorry.
I think that's the question in part here, right? So I've laid out a scenario where supposedly there's a mathematical proof that triangles have more and less and 180 degrees. I'd say that's impossible within the proof-based mathematics system. And Stefan Mudd says, first, yes, there is proof within mathematics that spherical triangles have more than 180 degree internal angles, proven by Legendre's, Girard's and Gauss-Bonnet theorems of spherical geometry. And as we know, a mathematical theorem is proof. There are two different types of triangles, planar and spherical. Why should there be a contradiction?
Because adding this spherical means that we are dealing with not triangles. This is the difference for me, because normal triangles having 180 degree, we have this rigid number. So what is number of spherical triangle for angles? And there is no answer for that.
Yeah, you can't have a proof of something where there is no answer.
Yeah, because every triangle, depending on this spherical triangle, is dependent of the size. So if it is bigger, it has more. So this is just ridiculous.
Is a theorem a proof?
You can have the Pythagorean theorem, right? Pythagoras' theorem.
A theorem, it's a sort of proposition. You propose something, and then you go through the logical steps that you would need to either prove or disprove the original proposition.
So a theorem in itself is not a proof.
You can say that this is proof because it is proof inside of that. But for me, this is like it's obvious that in these spherical triangles there is more, but they are not triangles. That's the problem.
Yeah,
because
we've been saying for quite a bit. It's just 3 circles.
yeah, 3 circles intersecting. Yes. So what?
Yeah, it's definitely not a triangle because you don't make triangles from 3 circles. It's just 3 circles.
If I could add to that, I would say that the 3 circles you're talking about are all of equal size as well.
Yes, and in normal triangles, you can have different lengths of sides, and in spherical triangle, that would be very difficult to make that kind of triangle with the different sizes of this spherical sides.
Yeah, well, a triangle is defined within geometry as a trilateral figure, which is a figure enclosed by 3 straight sides. And a spherical triangle is not that, aka it's not a triangle. It's, like Bev said, it's 3 circles. And I will add that these 3 circles are of equal size. They are planes that all intersect at the same point. And that's where the angles are measured.
Yes, in normal triangles, you can have Pythagorean theorem. So in spherical triangles, it doesn't work, and Thales proportions will not work also. So it is just useless.
In doing spherical trigonometry, you require trigonometry, which requires the 3 points of a triangle with 180 degrees. So even within spherical trigonometry, the triangle with 180 degrees is used and needed. There's no way of getting around the fact. This is why we keep saying that a triangle has 180 degrees and it's needed to be a triangle just so any of these calculations can be done. So anything involving trigonometry involves a triangle with 180 degrees.
Indeed. And I want to clarify as well, it's not that triangles have 180 degrees for the necessity of being able to do these calculations. It's the fact that triangles are proven to always have 180 degrees internal angle that's the basis of being able to do these calculations in the first place.
Yes, because only having this number of angles and straight lines, you can have proportions, because trigonometry is based on proportions between angles and lengths of the side. So without having these proportions, you cannot have trigonometry.
Yep.
So, I'll carry on. Anyone think that there isn't a contradiction? Because that's what I've noticed. That with the model seems to come an ability to not see contradictions. Anyone see a contradiction with the triangle having 180 degrees and there being a mathematical proof for that? And then somebody imagining 3 points having a different thing than that triangle. Is that not being a contradiction? Because Stefan Mudd here says, so why should there be a contradiction? Anyone else see a contradiction within that, or is it just me that sees the contradiction in that there?
Contradiction is that spherical triangles don't meet requirements for being triangle. So that's contradiction.
His blue marble comes in when he says, spherical triangles are not planar triangles, Bev. That's a triangle, right? 3 points. Define a plane. That's a triangle. I don't know how you can be any other way, right? I literally, I can't work it out for the life of me what's going on. Spherical triangles are not planar triangles. Obviously.
Yes, and by the way, by connecting these 3 points, you are creating plane. So, requisition for a spherical triangle is some surface, some sphere, strangely enough.
Yeah, I
So
mean,
you are
just because there's a sphere there, does that stop you from having 3 points making a triangle, since a triangle's
no.
a mathematical construct, right? It's just made up of 3 points.
Yes, you are doing that in space. So requirement is not curving surface for triangle. You have space, 3 points in space. You connect them with straight lines, and you have plane and triangle.
But since a line, straight line, is one-dimensional, it doesn't exactly exist either, does it? So
yes,
the triangle is irrelevant because it has 3 points, that of which has no parts, and a one-dimensional line connecting them.
Yes. You in space you can do that. On a sphere you cannot. So you cannot connect these points on a sphere with straight lines. So this is one requirement for creating triangle. So it does not meet this spherical geometry. It does not meet this requirement. So you cannot create triangle. Any figure. You cannot create squares, triangles, octagons, whatever.
But doesn't the sphere exist in 3-dimensional space?
Yeah, of course.
Mm-hmm.
And wouldn't each point on the surface of that sphere also be in 3-dimensional space?
It will be, of course.
So why can't you make a triangle with those 3 points?
You cannot, because
Well, you can. You can make the triangle. It just won't be on the surface of the sphere. It will still be a triangle.
Yeah, that's what I'm getting at.
Yeah.
Yes, because triangles, they are, and squares, etc., they are planar figures, two-dimensional figures. On the surface of the sphere, you cannot have any two-dimensional figure.
Yeah. Johnny's in the chat. Johnny, yes. 3 circles, we know, right? You happen to call it a triangle. Like I think I might be able to speak for everyone here, is we think that's a misdirection. It's just an untruth. It's not a triangle, because triangles have 180 degrees, as everybody knows. That's not because we say so. It's because it's provably so. Provably so that it cannot be anything else. That's how we know it's provably so. So when somebody says you can have triangles with more than 180 degrees, that sounds contradictory.
Because it is.
Yeah.
And by the way, you can intersect two circles, for example, and you have a planar figure called vesica Pisces. So there is no problem with intersecting circles, but still you can create vesica Pisces being planar figure. So we don't have any problem with intersecting circles, but on a sphere you cannot create vesica Pisces even.
It just seems strange to me that when you say that there's a mathematical proof of a triangle having 180 degrees, people have to contradict that, to say that spherical triangles have more, as though there's a different sort of triangle that has more than 180 degrees, which is an untruth. It really, what they mean to say is you can draw 3 circles on a ball and imagine that's a triangle, and then measure the angles between the planes of those circles, and then say that those are the internal angles of the triangle that isn't actually a triangle. It's fantastic.
Yes, and there are some impossible implications, because in normal triangle you can mirror another triangle, and you will have a rectangle with the hypotenuse as diagonal, and this rectangle will have double sum of 180 degree, and this is always will happen. But on the surface of the sphere, you cannot create a rectangle from 2 spherical triangles with the same sum of angles. So you cannot progress in geometry on a sphere. It's just nonsense.
If you have 3 intersecting planes, they all intersect the same point, then that's the point where you're going to be measuring the angles between the planes, right?
Johnny's saying that it's 2D. Johnny in the chat saying it's 2D, but it can't be 2D because, like as Saragaki says, the angles are measured on the planes internally.
I mean, there's no other place you can measure the angle.
It's like an eighth, or like if you can imagine a quadrant of a hemisphere, is it? Semisphere?
I think they say hemi nowadays.
Well, a quarter of a hemisphere is not 2D. Quite obviously.
Very definitely,
Absolutely. Yeah, this is 3D angle.
Okay, so well, let's carry on. Blue says, if triangles on the surface of a sphere can be proven to be planar, or all spheres can be shown to have a radius that approaches infinity, even though we can see they don't, then all triangles have 180 degrees of internal angles. Can you provide your proof for that? Can you prove all triangles have an infinite radius? Or that spherical surfaces are planar?
Triangles don't have
radiuses.
So.
Yeah. Blue? Are you sure you meant to write that? That is Blue Marble that wrote that. Let me just check he wrote that right. Let me just check. It says, even though... Oh, no, wait a minute. Let me read it all. Spherical triangles are not planar triangles, Bev. But Johnny Ragadoo just said that they were 2D. And 2D is a plane
Plane is
length times
2D,
breadth.
sorry.
Yeah. So you seem all confused, guys. I'm not. But I'll carry on, right? Spherical triangles are not planar triangles, Bev. Do you think you can draw a planar triangle on the surface of a sphere? Question mark. If triangles on the surface of a sphere can be proven to be planar, or all spheres can be shown to have a radius that approaches infinity, even though we can see they don't, then all triangles would have 180 degrees of internal angles.
That's really bad.
Can you provide proof for that? Question mark. He's asking me. I can provide proof for his... I don't know. Can you prove all triangles have an infinite radius, or that spherical surfaces are planar? Like, spherical surfaces are 3D, Blue, quite obviously, because the sphere is 3D in Euclidean geometry. It's 3-dimensional, and yeah.
And by the way,
Triangles
if you have,
don't have radiuses.
yes, and still, but even by we measure angle using a section of circle, but you have to establish distance between a point of intersection and this radius. So if radius is infinite, you cannot do that. So you cannot measure angle anyhow with infinite radius. It is just impossible.
Right.
Well, I mean, if you have two intersecting straight lines, they can be however long.
Yes, yes, of course. Then yes.
What I find fascinating is he goes through and if this and that, then all triangles would have 180 degrees of internal angles. See, I think that's the strangest part, because triangles are already proven to have 180 degrees of internal angles, regardless of the if this and that Blue is positing here. So him holding up two impossibilities as a shield towards that fact is pretty strange.
I was thinking, is this the sort of thing that he's asking himself? And he's wanting, like, he can't find clarity himself. He's wandering about aporia. Betty's been over there and handed them aporia. Now Blue's wandering around, muttering to himself, asking himself these questions that he can't answer. Like asking us, can you prove all triangles have an infinite radius, or that spherical surfaces are planar? Like I've said ages, spherical surfaces, like the ball, is 3D. A plane is 2D. So I don't understand why Blue's asking us to prove it. You should be able to prove that a straight line lies within a plane and not without it, right? You can't have one part of a straight line lying within a plane and another part outside of that plane. It doesn't work, right? That can be proved, and that's sort of showing that the line lies within the plane. Blue wants to think that you can prove that on a spherical surface. Madness.
Okay, but this is not plane, because even in their spherical geometry, they have or they use a horizontal plane. So, and this sphere is tangent to that, may be tangent. And
That's
this is
Euclidean.
tangent only at one point.
Tangent is Euclidean.
Yeah, but only one point. So you cannot have straight line lying on this plane and being 2D and being 2D also on the sphere. It is impossible.
Well, Blue Marble, I've heard that Blue Marble is going to be doing a demonstration of the basics of spherical geometry. I mean, we have said many times it's just a circle on a ball, not really a triangle, and calling it a triangle is giving everyone the wrong impression. But there's a lot of people that like this. I think the model Afflicted. I say to Blue, I'll wait for your demonstration to show how triangles can have more internal angles than a triangle. There are some of your friends who say they have a proof for triangles being different than triangles. I hope they will be willing to help you with your demonstration. And Blue comes back with, your ADHD has kicked in again, Bev. I'm not doing any demonstrations. Blue's not.
What?
It's not going to help anybody with these simple demonstrations of
So there's
spherical
been
geometry. Yeah, he's keeping it secret.
there's been developments then, because like I haven't been on YouTube in a couple of days, but last time I was on, I made a comment to Blue where he specifically stated that he'd be happy to go over this in basic ways, basic terms.
Yeah.
So I wonder what happened across the weekend, because I haven't been paying attention.
Blue. Wow.
I have slight suspicion that he cannot demonstrate that.
Obviously not. Blue's lost at the minute. Like,
Could I make a
seriously.
guess? I would wager a guess. I guess you can't even say that, but that maybe Blue went and read up on some Gauss over the weekend.
It was
No, you don't
Stefan.
think?
No.
No, I guess you're right. I
No,
mean,
he's
he
just
has.
shy. He's science. He doesn't really want to do mathematics, right? But at some point, this modern science is going to have to creep into mathematics and sort of science mathematics. I think that's what this is. This is part Blue Marble scientific method, part dogmatics. It's basically the sophistry within mathematics through modern day science. And he's just a bit shy. But he's going to have to do it at some point. He's going to have to show them. Because, I mean, like, circles on a ball don't really work it. And they're not really going to cut it, are they? Nobody's going to believe that that's a triangle. When PhD mathematicians tell you that spherical geometry is actually Euclidean because of the circles and the planes and the angles between the planes. You have a bit of it's a hard job explaining the not that once you're faced with Euclidean as the that. It's a bit hard to describe or imagine something other than that, I think. But that's in the hands of the Blue Marble scientists and the demonstrations that we probably won't ever see. He might keep them private, right? He might just do them within his Discord server.
I would certainly hope not, but I do believe you may be correct.
He says, I'm not going to do any demonstrations. I've already told you that. You're going to submit measurements proving level is horizontal over a distance of 13 miles.
What?
You can do that from the beach at Southport with an auto level or a theodolite. All you need to do is point the device at Blackpool Tower on a clear day and see where the crosshairs is hitting the tower. This is blue marble science, I'm telling you. This is how we do it. Every elevation on that tower is well known. So it's just like your stick with numbers on it. Your instrument is establishing a horizontal plane of reference. You admit that. The ocean is next to you on that beach, so your crosshair has to be at the same elevation at Blackpool as it is at Southport if level is horizontal as you claim. We are looking forward to your measurements, Bev. Best of luck. He's under the delusion that, you know, when we went to do that demonstration of how the guy who said that he made a video showing that plumb lines aren't parallel, and we said he's a lying shit because you can't actually see that measurement that he's telling everybody he's measured and just wrote down in his book. And we went there and we showed everybody that he was indeed a lying bastard and he's never actually measured those angles. Blue thinks that was a measurement of Blackpool Tower or something. It's crazy. It's crazy. I think his mate Chaiki told him for a laugh. And he believed him. Blue Marble actually thinks you can survey 13 miles away with an auto level.
Yeah, I was gonna say, like, he says, so your crosshair has to be at the same elevation at Blackpool as it is as Southport. I mean, the crosshair is in the scope of the auto level. That's where it is, and that's the elevation it's at. So if you
Doesn't
do
change
actually,
at all.
no, exactly, right? So if you do actually establish a horizontal plane for 13 miles from wherever to Blackpool Tower, yeah, you're gonna see that it's on the same elevation because that's what horizontal is.
But Blue
But
Marble Science thinks that an auto level works for 13 miles.
right, and that's where his problem is.
Yeah.
Either this is model affliction, or this is just speaking from ignorance because he doesn't actually know how the tool works.
Yeah, it's because his mate Chaiki's told him about something. Like, I believe it's a troubled mind. It's an exploded mind that believes this is fantastic things told of anyone. Now, I don't want to say Blue's one of these people that's highly suggestible, but it does seem that if you're the right sort of person, you can just tap into this Blue Marble Science guy and he will literally believe any old shit that you tell him, no matter how much stuff you can show them to the contrary, that we weren't doing that. That's not how you do it. You measure on the measuring rod. The measuring rod is a vital component of the auto level. You need an auto level, a tripod, and a measuring rod to be able to do any differential leveling at all. Blue Marble Science will tell you can look at things in the background. Well, you can't. Well, things are in the background, but they bear no resemblance to any of the surveying procedure that goes on. So it's got more replies though. Stefan Mudd, he's trying to get Blue Marble into this. He says there is proof within mathematics that spherical triangles have more than 180-degree internal angles, proven by Legrand, Girard and Gauss-Bonnet theorems of spherical geometry. As we know, a mathematical theorem is proof. Again, he's repeating the same thing, and we say we've been over this many times. The angles are measured internally on circles, from planes of circles to planes of circles. That's how Gauss did it. It's just to start off with a sphere. draw
cutting through the object, correct?
Yeah.
Yeah, because that's where the angle would have to be measured at the center point of the object. No.
Yeah, within the angles are measured between the planes, and
Right.
when the planes intersect, they intersect at an angle, right? That
Yeah.
angle doesn't change; it stays as an angle, and
Yep.
obviously the circles can move.
Mm-hmm.
He says, why do you continue to ask for proof spherical angles have more than 180-degree internal angles? So why do you continue to ask for proof spherical angles have more than 180-degree internal angles? I think he's spelled that wrong.
I think he's triggered when he's writing this.
Yeah. But I've never asked for proof of all of that. You know, I just say triangles have 180 degrees. That's all I say. I'm not asking for anybody for anything else. I don't need anything else. I know, and I'm quite happy and secure in my understanding that triangles have 180 degrees. I know anybody else doesn't have an idea of what a proof is, because you can't contradict that proof. It's crazy.
Okay, but you said that there are 3 circles, and every circle has its own plane, right?
Yeah.
So we have 3 planes, different planes. So if we have 3 different planes, so we are operating in 3D.
Absolutely.
So it proves only that this triangle is not 2D. Sorry.
Mm-hmm. Absolutely.
It's like when you give your pet dog a name, you call it Rocket. Like the dog is not actually a rocket just because you named him or her that. It's just a name. Like spherical triangle is a name given to something that's not actually a triangle.
Yes, absolutely. Yeah.
So holding up in dichotomy, planar versus spherical triangle, is ridiculous.
Absolutely. They can't. You can't compare 3 points and the shortest distance between those 3 points to 3 circles.
Absolutely. And in a triangle, all the angles are measured at different points, 3 different points. While in the case of a so-called spherical triangle, all the angles are measured at the same point.
Which is impossible, because at point of intersection you cannot really measure angle. It is theoretically impossible.
Well, the point of intersection of the 3 spheres is where you would put that little center dot of your protractor, right?
Yeah,
That's all I'm saying. And all 3 of these planes do intersect at the same point. So that means you have, X amount of different planes to measure angles between. Each plane would...
He says there, are you incapable of reading up and understanding the theorems on your own? No, we have.
No.
We literally have. We went over it the other day, didn't we? We went over, here's Gauss, and here's Gauss's explanation of what you call a spherical triangle. It's 3 circles, angles between the circles, internally, measured internally on the angles. The 3D, like paper says.
Yeah, but these are angles between planes.
Yeah.
So
just Euclidean planes, right? A traditional angle, not between a curve and a curve, between planes, literally between planes.
So if you have 2 planes inclining, so you are measuring angle just using straight lines anyway.
Yep.
It's only mathematics. Oh, hey, I'll say OTL, yeah. And Paige says, no such thing as tilted verticals. We have squares. Blue's asking, how are the distances between the vertices of a spherical triangle measured? The distances between the vertices.
The vertices, you mean that one point at the center of the sphere where all the planes intersect? Yeah, there's no distance between a point and itself.
How are the distances between the vertices? All of the vertices. Because they like Saragaki says, right at the center. Boom, monad.
Mm-hmm.
Jump on the monad. I don't know. Tell us, Blue. Please explain to us using simple, basic understanding. We don't know, Blue. Distance between all of the vertices are at the center. That's where they all meet. So the distances between them, I'd say nothing.
Yep.
But hey, he says, is that why you ask the same question over and over? I'm not aware of me asking many questions to Blue Marble scientists because I know they're ignorant of it. And they just seem to get triggered by questions. So what you're best off doing is just explaining them as basically as you can what you understand. And then they'll tell you what the reply will be, right? They'll obviously explain it. Like Blue Marble Science says, we don't understand spherical triangles, whereas we say it's just 3 circles within a sphere. That's what we understand. Now, he says whatever he wants to say. And then hopefully he'll do a demonstration of it himself, and then he can explain exactly what he's talking about. I say there are no contradictory proofs within mathematics because of the law of non-contradiction. This law cannot be avoided or disregarded. They're quite good on these laws of logic within mathematics. So you can't have a proof of a triangle having 180 degrees, no more, no less, and then have another proof that says triangles can have more or triangles can have less. I mean, it's contradictory. It doesn't work. And Stefan Mudd says, but what is the mathematical contradiction between planar and spherical triangles?
Triangle is a trilateral figure enclosed by 3 straight lines. A spherical triangle is not that.
Yes, and by the way, triangles, you can prove that triangles have 180 degrees. So the contradiction is that if you can prove that triangle have more or less than that number, that would be contradictory proof. And it means that one of these figures would be not a triangle. You have to choose.
Or not a proof.
Or not a proof, but whatever. It would mean that one of these figures is not that.
He says, but what is the mathematical contradiction between planar and spherical triangles? This is what you have to explain. I think we've done that quite well. Just invoking the law of non-contradiction as an argument, this without explaining or giving evidence mathematically for what the contradiction is.
This is what I've said. So
yeah.
If you have 2 proofs which are excluding they are mutually exclusive. So you have contradictory proof. So one of these things have to be false. Has to be false.
I would be careful at this point, actually, because the dichotomy is holding up is planar triangle versus spherical triangle. Now, his misunderstanding, obviously, is the idea that spherical triangles are triangles, like three-sided figures enclosed by not straight lines, which is not true. So saying that there is no proof that spherical, or that it is not proof that spherical triangles can have more, when you know that this is three planes and the inclination between those three planes, I mean, these are two very separate things. Like, triangle doesn't have two different species of planar and spherical.
Yes, yes. So this proof, as I said before, this is on a sphere. So every circle is on different plane, and proof for a normal triangle is on one plane. So if you are using three different planes, it means that for me this is just would be not a proof anyway, because if this spherical triangle operating only on the sphere, that would be maybe a proof, but using three different planes, that would, for me, it is just misleading or deceiving, but absolutely does not prove spherical triangles, because there is no sphericity here.
So the term itself, spherical triangle, is an oxymoron.
I would say so. Spherical triangle is literally an oxymoron. Yes.
Mm-hmm.
Yeah, because you require one surface, plane or sphere, let's say. But to prove spherical triangles that they have excess, you use planar geometry for that. So you are not using at all this surface of the sphere. So it is completely redundant here. So it does not prove sphericity of these triangles, spherical triangles.
Yeah, I mean, the so-called spherical triangle, number one, it's not spherical. And number two, it's not a triangle either.
Yes. That was my point, that this is not spherical triangle. This triangle called spherical triangle is not spherical triangle. They should abandon this spherical before that.
Another one. There's plenty of contradictions. I'm pretty sure people can see the contradictions. Blue Marble says, Blue Marble Science, the YouTuber. Instead of all the arguing and denials over the existence of spherical geometry, why don't you simply admit that you don't understand it, or admit that your education didn't go that far, and state your preference to stick with the very basic planar geometry rather than attempt to learn a more advanced form? Most people would easily understand a man beyond middle age not wanting to take on a new challenge like this, especially if math wasn't one of his strong suits to begin with. We don't need spherical geometry to prove that level is not horizontal. Measurements of drop from horizontal are easily obtained, as you have shown numerous times, and reciprocal zenith angle measurements show exactly how verticals diverge. As Richard Feynman said, if test data disagrees with your hypothesis, brackets, in your case, a supposed geometric proof, your proof is wrong. So it seems silly to argue over whether advanced concepts like spherical geometry exist in reality if you aren't in a position to provide an intelligent argument to the contrary. I, for one, would be perfectly happy to keep the discussion at a very basic level that you can understand. That's
See, this is what I mean.
yeah.
That's what I meant when I said I haven't been paying attention over the weekend. This is the comment.
Yeah.
He said he would be happy, perfectly
Yeah.
happy.
To keep the discussion to a very basic level so that we can understand it, right? Well, we can understand Euclidean, obviously. So keep it at that level and explain it. Please, Blue, please go. We're asking for it. But what he says here, right, is wrapped up in this. Think showing his mind breaking a little bit. He says most people would easily understand a man not, especially if math wasn't one of his strong suits to begin with. We don't need spherical geometry to prove that level is not horizontal. Okay. You can't prove anything because he has no proofs. But I mean, that'd be interesting to see. Measurements of drop from horizontal are easily obtained, you have shown multiple times, and reciprocal zenith angle measurements show exactly how verticals diverge. As Richard Feynman said, if test data disagrees with your hypothesis, brackets, in your case, a supposed geometric proof, close brackets, that's of triangles having 180 degrees, your proof is wrong. Yeah, everyone get that?
Yes, but still,
So
he's
Blue
talking
Marble.
about this
Blue Marble's
dropping.
no. Blue Marble's talking about test data that he has of angles being more than 180 degrees, being counter to the geometric proof of triangles having 180 degrees. That's literally what he's saying. Your proof's wrong. The proof of triangles having 180 degrees, Blue Marble imagines he's disproved that because of reciprocal zenith angles measurements done by Jesse Kozlowski and Larry Scott. He thinks Larry Scott and Jesse Kozlowski have proved that triangles don't have 180 degrees.
That's very interesting because, I mean, I listened to him and Flat Earth Math, Charles, have a conversation not too long ago, a couple of weeks maybe, and they were talking about how it's like practically impossible to do this measurement that he's now saying is easy.
Well, yeah, and we've proved that he can't do it. We right the guy who obviously doesn't live in Maine. How he lied about the measurements that he took. We've proved that.
Yep.
So, I mean, Blue Marble Science seems to be saying that, well, what's the supposed geometric proof, Blue? We've got a proof that triangles only have 180 degrees. I mean, that's provable, Blue. But you say the proof's wrong.
Blue, if you come over, have a chat, like we can go over it step by step in excruciating detail if needed, that triangles do indeed have internal angles summing to two right angles.
Oh, well, actually, that's similar to your perpendicular proof as well, isn't it? You know, two right angles, same thing. A straight line.
Yeah, they're...
It's a straight line having perpendiculars at either end, summing to...
It's just two different conditions of axiom 12.
Yeah.
Like my proof of the two perpendiculars to the same plane being parallel, 180 degrees, goes hand in hand with axiom 12, which allows for this parallelism to actually exist.
Mm-hmm.
It's right there in the axiom itself. So yeah, they do go hand in hand.
And that's why Blue Marble has to have more within the triangle. I'm not too sure whether he actually realised it or not, but obviously the exploded mind gets to this position, and it gets tricky. Even Blue, that we've had words with PhD mathematicians, and unfortunately, they don't seem to have exploded minds like the modern scientists do. It's very strange how people think that they're telling us about things that we already know about. Rumpus is in the chat. Don't listen to Rumpus. He's imagining and he's a surveyor again. Like that other guy who imagines he's a scientist and a mathematician that's proved that triangles don't have 180 degrees. I mean, it's fantastic, we know. But these are the claims of the people that are around us. We keep it to advanced simplicity. We keep talking as simple as we can. Yet, these scientists, fantastic.
Can you go over this blue marble science comment? Because that's interesting.
Which one? The one in the chat or the one in the...
In the YouTube one, yeah. The latest one he just posted.
So try reading it again, Bev. I said drop from horizontal is easily provable.
It is. Yeah. It is. That's a vertical distance measured from the... Yes.
Yeah, you might have seen me, Blue, with the measuring rod. That's how we prove drop from horizontal, by measuring that.
Directly. First order measurement.
Yeah, I don't know what you think, Blue. Is that... How does that prove that? Like, we know that drop from horizontal is definitely measurable on the vertical datum. That's what the measuring rod is for. Rumpus, are you round at Blues? Can you help him out? Is there somebody out there to help Blue? He seems to be. I don't know. Anytime you want, Blue, to imagine that you can keep it to basic for you to talk about spherical geometry.
I mean, surely nobody is trying to equivocate or conflate between spherical triangles and spherical geometry, because spherical triangles do not exist within spherical geometry.
I say, as a reply to that, 28 replies. It says, it seems like you're the one denying mathematics, Blue. I've just had a conversation with a mathematician and he agreed with me 100%. Our understanding of both reality and what you call spherical triangles is completely Euclidean. Once again, Blue, it seems like you're thinking of imaginometry when we're talking about reality. Nice wall of meaningless text to explain your confusion, though. Blue replies. I think this is the one where we all replied. Again, Bev, we all see that spherical geometry is beyond your capabilities, and that's fine. Like I've said, Blue, I've been talking to mathematicians, and the only thing we have to go off is Euclidean. Gauss agrees, mathematicians agree. So the only one that disagrees at the minute is you, Blue Marble Science, and obviously support group Rumpus. Not much help from anyone else, I don't think. You've just got the you and Rumpus, but leading the charge well. Mathematics. We all see that spherical geometry is beyond your capabilities, and that's fine. The vast majority of people never heard of it either, but that doesn't mean it doesn't exist, or that you're allowed to make up some imaginary term for it just because you're ignorant of it. Just be honest for once, admit that you don't understand it, and move on. The same thing applies to other fundamental mathematical concepts that are obvious to those of us that studied higher level maths. Many of those concepts will forever remain a mystery to you, and that's okay. but don't expect the rest of us to operate at your level. Please don't try to tell us that we can't find the angle between two intersecting curves because you don't know how to. We certainly can. Don't say that we can't find a normal to a curved surface. I never have. Of course we can. You aren't being asked to learn how to do it. You obviously don't understand the principles behind these concepts, but your knowledge level is not what defines the upper boundary. Just sit back in bewilderment and consider how lucky you are that some really smart people figured out how to do all of those things you can't. That Blue Marble's never going to show anybody that he knows. So just everybody imagine that you can sit back in bewilderment, and because you don't even know what Blue Marble's talking about. It's fantastic, isn't it? The way that somebody can do that and say all of that sort of stuff, and then say that nobody else has ever even heard of it either. Just sit back and look at the amazement of things that go against proofs in reality. That's
I mean, what else can you do?
Yeah.
What other reaction would be appropriate? Because if somebody is sitting there spouting literal nonsense, what else do you respond with but bewilderment? Like, how can you be on this sort of nonsense right now?
And Stefan says, how can you learn something new if you deny it exists? So first off is step one. You have to say that spherical geometry exists. But hey, there is only Euclidean, so how you can have something that isn't Euclidean, I'm not too sure.
Again, a step has been taken here, which is about this conflation between spherical geometry and spherical triangles. Like, I'll easily say that spherical geometry is an imaginary geometry and illogical, but spherical triangles are within spherical trigonometry, which is all Euclidean. There are three circles. They are planes. Their angles are measured between the planes, straight lines. Like, nothing's wrong with that. So saying that spherical geometry is an imaginary geometry does not mean you're also saying that spherical triangles do not exist. But of course, pointing out that they're not actually triangles and not actually spherical is kind of important because of the naming of the thing.
Yeah, it's a part of a sphere, right? If you want to call the part of a sphere spherical triangle, then be my guest, but don't counter the fact that triangles have 180 degrees with spherical triangles have more, because that's ridiculous. It's almost as ridiculous as saying, well, a square has 360.
Yeah, like have two intersecting perpendiculars and measure only 3 of the 4 right angles, right?
Yeah.
Oh, look, a triangle. No, they are 3 individual angles. That's 270 degrees. Well, yeah, but you still don't have a triangle.
Yeah, you can't just add them together because they're 3 separate angles and imagine it's a
Nope.
triangle. I mean, that's ridiculous. But hey, that's what some people are doing. We call it imaginometry because it has to exist in 3D, and 3D is Euclidean. It's the only geometry that makes it into the third dimension, i.e. reality. All of the other ones are 2D. Hence, this is my reply. I take it you didn't look into spherical geometry, brackets, trigonometry, to find out the angles are measured between the planes of great circles that form the lines on the Euclidean sphere. If you had, you'd know that this shape you call a triangle is indeed made up of 3 Euclidean circles. I'm not sure how you found yourself in this position, but your ignorance and lack of understanding of basic geometric principles deserve to be shown. We accept your willingness to demonstrate spherical geometry on a basic level. When can we schedule this? We are all willing to take part on your mathematical demonstration to show how spherical triangles exist. It's about time we all learned a little bit about spherical trigonometry and how it differs from imaginary geometries. I look forward to this new mutual learning possibilities for the practical application of this mathematical concept.
There you go. You got it in there. How it differs from imaginary geometries. That's it.
Mike says, I'm really looking forward to you explaining the spherical geometry that your education took you far enough to learn, Blue. Very generous of you to offer to try to teach it to us. Nothing like learning from one of the self-professed, really smart people. And then Saragaki, yeah, I would love to listen to this topic being discussed at a fundamental level. Thank you for taking on this task, Blue. It will be very much appreciated. So I think everybody deserves to get behind this. I mean, we all could learn from showing how spherical trigonometry, Euclidean, differs from spherical geometry, blue marble imaginometry based, that you have to be really smart, and that very many people have made that leap from real geometry to this imaginary geometry, whereas blue marble has. But he's already said that he will not be doing it. It must be like part of the magic circle or something, that he's unable to be able to present any of this, obviously, imaginary geometry. So over the coming whatever, we will have more discussions about these sort of things, because obviously.
May I ask a couple questions?
Yeah, of course.
Because I honestly don't know. Blue is not a mathematician by trade, is he?
Oh, he's obviously studied higher level mathematics. Although I don't know whether it was as high as the PhD mathematician I was talking to the other day. But well, I mean, I don't know. We'll have to let Blue tell us that.
Well, yeah, I was just wondering what maybe we'll find out eventually. But I was just wondering what a real real mathematician would say about these particular issues. It'd be interesting to find that out.
Oh well, a real mathematician would say that all of this stuff is Euclidean. Got to go completely against anything that Blue Marble's saying, but I mean, it might be a good chance for us to learn about Rumpus's qualifications and exactly what Rumpus's degrees and all of that would be in, because like you hear about these people who are experts at multiple things. Well, Rumpus must have a long string of very high qualifications, especially within mathematics, you'd imagine, wouldn't you?
Mm-hmm. Absolutely.
So you never know.
Yeah, you have to imagine.
Blue Marble would definitely be getting all of his best team members, because, I mean, like we say, I've talked to a mathematician, and like he was just a PhD mathematician. He was no flat Earth mathematician, right? I mean, I don't know whether Rumpus and Blue and these new modern science guys that can maybe there's other people that can help him, Blue, do the demonstration. I mean, nobody says that you have to do it, Blue, but you do have the platform to teach people these sort of things that you're saying, right? I mean, it would look really bad if you just kept saying not that and then never actually showed anybody anything. But I mean, this is Blue Marble science, right? It could be part of the Blue Marble scientific procedure and the scientific method to just scream not that whenever anybody's actually explaining stuff. But I mean, hey, I don't know.
Well, I see. I would have guessed myself that somebody, before making all of these claims and then chastising a group of other people around this issue, would probably have wanted to speak to a PhD in mathematics, but perhaps they haven't. Maybe they can't or don't want to. I don't know.
Maybe I don't know whether they can actually talk to a PhD mathematician, because I mean, what if the PhD mathematician went against something that they said? I mean, you know how they are. The new blue marble scientific method states, I think it states that you're always correct and everything can always be modern scienced, right? There is no proofs.
It would be interesting to listen into that conversation for sure.
Well,
And before you move on from this comment, I want to underscore that Blue, you have the opportunity right now to not, don't do this for, Bev or me or Mike or any of us. Ignore us. Just do this for yourself and for your followers or whatever, because clearly you need higher level learning to get to the point you're at, Blue. And surely you don't think that all of your followers have the same level or even higher level education than you. I mean, you may believe that, but certainly that's a little strange to believe. So I think it would be good for everyone. And certainly the fact that this is a controversial issue, which has a bunch of disagreements tied up in it, surely you'd want to untangle the confusion and make this clear so that everyone, no matter their ideology or whatever, can actually understand what this conversation is all about. This is pretty important stuff right here.
yeah, I think Rumpus doesn't think that anybody's got a PhD in maths. They do give them out, Rumpus. There are people that have PhDs in maths.
Well, that would tell me that
That
Rumpus
Rumpus
does not
hasn't.
have a
Yeah,
PhD in mathematics. That's for
yeah.
sure. Yeah, yeah.
Wow, that I would suggest that Rumpus might not have a PhD in anything from that comment. But I mean, who am I to say? I'm pretty sure Rumpus is one of the blue marble scientific experts. So he would definitely have to have some science based thing, if not mathematics, as well. Like blue marble's obviously done this higher mathematics where they go out of the mathematics of reality.
Let me help Rumpus out if he wants to look in our live chat. He's free to take a look there. I just put it was the first link that came up. It was Stanford. I mean, no one's really heard of Stanford. It is a U.S. university. I mean, it's clearly not an Oxford by any means,
I'll put it there
or a Cambridge. But yeah, PhD program, mathematics.
He says, I don't. Oh, right. I don't, Rumpus. Wow. Well, then, Rumpus. Challenging. I'll make sure, Rumpus, just for you. Rumpus knows people with PhDs in maths. Well,
That's contradictory then.
You think?
I mean, the rumpus has stated very clearly that the rumpus is always correct. So whether or not that's a blue marble scientific procedure or not, he's at least stated it about himself. So since he doesn't have one, then neither can anyone else, except the people that he knows that has one.
yeah. Yeah, and I definitely wouldn't know anybody with one because that, I don't know. It is just mathematics, Rumpus, right? Like when we're talking about triangles having 180 degrees, that's a proof within mathematics, like in reality. So, I mean, that would be part of the understanding of people that know mathematics. I mean, it would be basic understanding. But people with mathematic training, let's say, they also agree that triangles do have 180 degrees. There's only a very small breed of people that seem to counter that statement with something about a different sort of triangles. But when they're talking about that, they're not talking the difference between a right-angled triangle and an isosceles triangle or a scalene triangle or you know, like anything like that. An obtuse triangle. That's not what they're talking about. They're talking like a different sort of triangle. Like triangles have 180 degrees and then a different triangle that doesn't, and not that.
Yeah, I find it really strange because, I mean, all the different species of triangle are defined within book 1 of Euclid. And I mean, I challenge anyone to come up with a new kind of trilateral figure that isn't defined within book 1 of Euclid. But there's a book 10, book 11, sorry, within Euclid, which goes to three-dimensional geometry. And since these so-called spherical triangles are inside the sphere, three-dimensional, you would kind of assume that these things would be defined in book 11, but they're not. So, I mean, I'm just curious. This seems like a really strange place to be in this conversation in the first place.
Rumpus says triangles come in several types.
Indeed.
There are planar triangles. This is how he's separating them. Planar triangles, spherical triangles, and others. Like that's a 1, 2, and others. And only for planar triangles do the angles sum up to 180 degrees. Well, it just seems that all triangles, Rumpus, like especially in reality, they're triangles with 180 degrees. That's what people know about. The question is, where do you measure triangles with more than 180 degrees? Where do you do that?
And that's why I posed the challenge. There are 6 different definitions of different types of triangles within book 1 of Euclid. So yeah, I challenge anyone to find any triangle that has not been defined within Euclid.
Rumpus is still fantasizing about going and doing the reciprocal. Are you doing reciprocal, Rumpus? Did you do that? Because I think we've got you beat. I don't know whether you're gonna be needed. When do you think you're gonna get down there and do it? We do the reciprocal Rumpus pole sighting experiment. I think Blue Marble. I've got a clip from Blue Marble today. He wasn't champion in your test. Can I find it? Let's see. Can I find it? He was champion in the reciprocal Rumpus pole sightings, you know.
He was, yeah. Rumpus. I mean, if I was you right now, I'd be, feel the fire lit up under my ass to go and get this done. Because if Bevan them goes out and do the reciprocal one, you're gonna be obsolete, Rumpus. Get out there, do something.
Yeah, I think I'll find it in a bit. He's not doing reciprocal, see? You can't prove anything then, Rumpus. The Blue Marbles after seeing the reciprocated one. Can't prove anything with just one way. Like the Blue Marble likes to laugh at it, but how do you know it's not just lower? You're measuring like Blue Marble says, a drop from horizontal, aren't you? That's an elevation change. How do you know you're just not measuring an elevation change? You've got to reciprocate it, Rumpus. I'm sorry, you're too far behind. Rumpus is just going to go and measure the drop of the water level. 17 foot. 17-foot drop, Rumpus imagines he's going to measure. Right, I'm going to read a few more of these things. Robert Baker, who says, wow, serious failure to comprehend from all three of you. Blue never offered remedial tutoring for you guys, but you act as though you pretend he did. To what end? Like, I think Saragaki's already said that. Just so Rumpus's viewers and his fans, the Blue Marbettes, whatever he wants to call them, his little, the Blue Marble scientists under his control. He's the chief. They'd want to know, surely. I say he's not teaching, he's just going to be explaining the basics. I'm looking forward to his demonstration, as no doubt you are too. Robert Baker says, Blue said, so it seems silly to argue over whether advanced concepts like spherical geometry exist in reality if you aren't in a position to provide an intelligent argument to the contrary. Triangles have 180 degrees. There's definitely an argument for that.
You can definitely have 3 axes mutually perpendicular in reality.
Yeah. So there's 2 arguments. But hey, I, for one, would be perfectly happy to keep the discussion at a very basic level that you can understand. He doesn't seem to be planning to discuss advanced concepts like spherical geometry. He is happy to stick with the simple stuff. That you are capable of understanding. Well, obviously, yeah, we can understand circles and triangles, squares, all of that sort of stuff. Wasn't Blue Marble Science the guy that said a 3, 4, or 5-sided square?
Yeah.
Okay, was that simple? Is that simple geometry or classed as higher geometry? I think
it's not within Euclid, so it has to be beyond Euclid, meta Euclid.
Yeah, just like taking one of the sides off a square and adding it to another one. Yeah, but obviously, so I say I'd be happy to witness Blue Marble Science demonstrating spherical geometry at a very basic level. It's nice of you to confirm his willingness to demonstrate and discuss this so that everyone can understand how the fundamentals work. Stefan said, would a visual presentation of Girard's theorem of the use of looms with explanation and math be simple enough? If so, you could go to Princeton University. Asking, is it? Yeah, help me, Blue. Blue says to me, it's interesting that you, Mike Jones, and Saragaki all managed to somehow read an offer on my part to teach spherical geometry to you into what I wrote. Now, I'm not particularly bothered about us, Blue. I said it would be good for people to understand the difference between spherical trigonometry that we've described very well and spherical geometry and how it differs. Like I said, we've already done the simple basics. You, Blue, can do the extra stuff simply. I read part of spherical do that into what I wrote. I didn't offer to do that. It's even more interesting that you're almost able to envision the intersection of 3 great circles and realize that the arc segments between these points of intersection form a spherical triangle. Isn't that what we've said? It's very
Well,
weird.
read that one again.
Yeah, it says, it's even more interesting that you're almost able to envision the intersection of three great circles and realize that the arc segments between those points of intersection form a spherical triangle. The very thing you deny the existence of. I said almost because you obviously still don't understand the difference between a disc and a circle, or a geodesic and a great circle. So again, there is little point in debating any of this. At your level, you're better off sticking with your simplistic understanding of planar geometry. Just don't try to use it to find the distance between Madrid and Perth, like we can do with the Haversine formula. And I would never need to measure the distance between Madrid and Perth. Just wouldn't even.
Perth is in Australia, which is on an island, which is not on the same continent as Madrid. How are you going to measure across the ocean?
With a Haversine formula. He does it with the formula.
If you go back, though...
He thinks you measure the side of an angle, the side of one of these triangles with an angle. Like, he literally thinks the opposite side to the angle is a distance. He thinks that the angle is the distance of the opposite side. You know, like when we said you can do fuck all with an angle. Blue Marble actually thinks that's the length of the other side, the opposite side, you know.
Yeah, I do, and it's sad because he's not the only one. But he did say here earlier in this comment, which I'm glad I already preempted this, because he says here, and realize that the arc segments between those points of intersection form a spherical triangle. Like, the actual arc segments do not come into it whatsoever. It's irrelevant to what we're talking about right now. So that's interesting that he's saying that, because this is why I prefaced it with the three planes and the angles actually being measured between the planes. That the actual circles, the circumference of them intersecting on the surface of the sphere is actually irrelevant completely.
Everybody in the chat, the YouTube chat, we're not talking about surveying in here. We're talking about triangles. So please be aware that don't just read the YouTube chat, because this is where the stuff's actually going on. There's some sort of, I don't know, fantasy stuff going on about stuff that we're not actually talking about in the live chat. A bit strange. But hey. I say, however you want to demonstrate spherical geometry is fine with me. I've already explained all I know. I look forward to your demonstration. Will you be doing it live, or will you prepare a video? I know he's good at preparing videos, scripting stuff like that. I hope that the prepared video, because I know he's not very good at doing live stuff. He's much better at writing scripts and doing all of that. His videos are always better when he does that. Bring Gladys back out again. What do you mean by spherical triangle, geodesic, and or great circle? Thanks for all your help, Blue. Can I get a shout out too? You're going to need to change your name, asking. Blue says, I have no intention of doing anything, Bev. It's all been done many times. Type spherical trigonometry into the YouTube search bar and you'll get pages of videos on the topic. And yes, we know. That's what we've been explaining to you all this time, Blue. Circles, spherical trigonometry. Entirely Euclidean. It's called trigonometry because you use the triangles that use trigonometry, the ones with 180 degrees. So you can't say you're using trigonometry in triangles with 180 degrees to prove that triangles have more than 180 degrees. That's stolen concept.
Very much so.
Literally.
Plus, there's some more hidden sophistry here because he's replying to your comment where you said you've already explained all you know, and that includes spherical trigonometry. He's the one talking about spherical geometry, which is what he should be focusing on. Instead, he's trying to tell you to research something you already have explained. It's weird.
And this one's quite a good one as well. This is Eric. Eric starts this one off. So thank you very much, Eric. Eric puts, Blue, are you claiming that spherical geometry actually exists in reality? Could you build something physically only using spherical geometry? Or is it just a 2D conceptual geometry that only exists in your mind and on paper? And you're going to have to come up with something better than reciprocal zenith angle measurements that aren't exactly actually measurements and don't prove anything. That trick has already been exposed. Why don't you do a test using a water level to measure the drop of level from horizontal? Jesse said it's possible, and the curve is measurable. He's even gave the rate of curve over distance. I don't see what the problem is, Blue. Why can't you recreate Jesse's test and physically measure level dropping from horizontal? Which is very good question, Eric. I'd say Blue obviously isn't going to answer it, right? But that's very good. The questions are there. Why hasn't anybody ever delivered on Jesse Kozlowski saying that the drop of the water level from horizontal is measurable? He even then had the nerve to ask me if I've ever done it. I would say if anybody's ever tried to do this, then that would be us. But we obviously had a realizing Euclid test. Completely different thing. So here we go with the replies. Stefan Mudd says, this is in reply to that. Have you ever heard about mathematical theorems for spherical geometry? As a, it doesn't help us asking why nobody's actually ever tried to measure the drop of the water level from horizontal, like Jesse Kozlowski claimed. Thank you very much, Eric. And Flat Earth Math comes in because he's he says this is a rebuttal, right? This is Eric. I don't know whether you saw this. Flat Earth Math says, hold a Earth globe in your hands. If I can give you 2 numbers, not 3, you will still be able to find a single unique location on that globe. That's an application of spherical geometry.
Bullshit.
Yeah, well,
What are these 2 numbers and how are they going to locate a point on the surface of a sphere, please?
it's just
That's to flat Earth math, right?
Yeah, that is, yeah. He says that's an application of spherical geometry.
But the sphere is
numbers.
Euclidean.
Yeah. Yeah, but the application of 2 numbers to a sphere is spherical geometry.
There you go. You should have flat Earth math help you with your video.
Yeah, you get what you do is you get a ball and you write 2 numbers on it. And that's an application of spherical geometry, according to Flat Earth Mathematics. And I think Blue replied. Bev said, he says, Bev already did it. Have you not seen his brilliant work at Blackpool? don't think anybody's ever seen the work at Blackpool, have they? I mean, I know
I
I
mean,
did it live when we were in Blackpool, but that's all
yeah, I
right.
don't know how many views you have for if you put that out as a standalone video, but some people have seen it. I'm not so sure Blue has.
And he's promised to do it again to ensure repeatability. I think he intends to make the same measurements at Bedford from both directions. That will be a stunning display of level dropping away from horizontal. The rumpus pole sightings.
Yeah, Blue is,
Blues.
backing you on
Yeah.
this.
Move over rumpus. We have backing for the reciprocal rumpus pole sightings. I really like it because it is the finale in a series of logical arguments, which Blue Marble giving me the recommendation or the backing behind it. It is all I needed, really, Blue. Thank you very much. I say, do you mean holding the ball or stand on the ball? I said, do you mean holding the ball or the stand the ball is on? Do you mean the one with the fixed axis or just the ball? I'm replying to Flat Earth Math now, actually, where he says, hold an Earth globe in your hands. Just the ball or the stand that the ball's on? Oh, Eric, 1 hour ago. It says no measurements were made at Blackpool. Exactly right. Just picture to show the working range of the auto level. It's crazy how many times it's been explained to you, but you still want to misrepresent what that picture actually shows. Why won't you do a physical measurement using a water level? Jesse did say it's measurable. Thank you very much, Eric. It's good. It's good to see that some people do actually understand this. The working range of the auto level shows that they're just lying when they say they can measure 2 fractions of an arc second. Can't be done.
Oh, and when you say fractions, I have seen some of these fractions. They are tiny fractions.
3 decimal places I've seen to some of them.
Yeah, 3 decimal places. Can you imagine? Everyone imagine that. That is 3 decimal points in the, seconds of a degree position. Which, how many parts has the angle been divided into already when you get to the second?
3,600ths of a second.
Exactly. And then what do you get when you have 3 decimal points of accuracy? I leave that to you.
Thousandths of a 3,600th, which it's been proved that you can't even see 3 seconds. Struggle for a minute. So, I mean, yeah, it's just fantastic. Unbelievable numbers claimed. This is Flat Earth Math again. He comes back. He's obviously keen to have a word with Eric. He says, just the ball, globe, stand is optional. So long as you have 2 understandings. The equator of a ball is 0 degrees latitude.
And that's just,
go on.
I mean, the equator of a ball, that's just a plane intersecting the ball so that you have 2 hemispheres, right?
Yeah, but like, is that a horizontal slice?
Or a vertical one?
It doesn't really matter, does it? It's just a slice through of the ball using the center. And he's calling that 0 degrees. But, I mean, you can't do that unless you affix it. That's the idea of the stand with the thing. So if it's just a ball, he doesn't know what he's talking about. But it seems like he's unaware that he has to fix it in the first place about an axis to start off with. Can't tell where an equator is of a ball because the ball can roll anywhere. It literally is anywhere. with positive latitudes being north and negative latitudes being south. The Greenwich meridian is 0 degrees longitude, with positive going west of there and negatives going east. So we have a problem. Oh, that's a problem. Using Euclidean 3 dimensions, every unique location on that globe would require 3 coordinates, x, y, and z. But because spherical geometry is real and practical, we can name every location on that globe with just 2 numbers. Two numbers.
That's fantastical.
Are they both degrees?
Did they not say that? Yeah.
So it's just 2 numbers.
Yeah, 2 degrees even. So 2 angles, basically.
2 angles, yeah. Any location with 2 angles.
That's what I'm saying. Blue and Flat Earth Math needs to get together and collab on this stuff.
And then I say, excellent. The reciprocal Rumpus pole sighting experiment has blue marble science. The chief of the blue marble scientists' approval. This means a lot. Thanks, Blue. And it does mean a lot. I think it's so good. Blue marble science has actually given his approval. It's a pity Rumpus. I don't know whether has Rumpus's drop from horizontal, the 17-foot drop, does that get the same approval? Just going one way.
I wouldn't know, but I will tell you that to the extent of my knowledge, I have not seen such
approval.
Mm-hmm.
Yeah, he's not publicly stated anything like that for any other tests, has he? Eric says to Flat Earth Math, that's not what I asked. And could you wrap a grid system around a banana if you wanted to? And you could wrap a grid system around a banana if you wanted to. That still doesn't constitute a new geometry. All you're doing is projecting 2D lines on a 3D object. Spherical geometry never makes it into 3D. Well done, Eric.
Yeah, that's spot on.
Yeah. Obviously, no reply. That's what comes of giving such a good reply, Eric, is you dead thread them.
Lewis doing what he suggested earlier, sitting back in bewilderment as he reads this comment from Eric.
And then here we go with Beddy. This is Beddy the logician. You guys want to see this because this is where it gets it into the Blue's got a definition of a flat earther. A Beddy, the chief dogmatician for the blue marble scientists. He says, definition of a flat earther: one who believes that a surface of equipotential on the earth is planar.
That's interesting on many points, but the surface of equipotential on the earth, is that required?
Nobody establishes this equipotential on Earth, because if he's talking about horizontal, it is in the air. It is above surface. Nobody is establishing a horizontal on the Earth.
I mean, like every surface of equal potential, that's what he said? Yeah, surface of equal potential. Every one of those that I know, they will be liquid, not earth.
Yes, they always add this on Earth. This is soletism for purpose. You can throw it out. This on Earth.
Mm-hmm.
Yeah, I'd say, because I could put water in a bucket.
It is, he's trying to define something, and whenever you should be defining something, in typical manner, you should state first off what it's the same as, and then how it's different from that. Betty's time decides to go for one who believes that a surface of equipotential on the Earth is planar. I don't even know what that means, but I put asterisk Betty's definition of people he wishes to show his particular form of bigotry towards, because that's all it seems to be here. He's making up a definition of something, just purely because he needs to a definition of this people that don't exist. Like, there's no such thing as an earther, and the Earth obviously isn't flat. Betty
And
just
how
wants to point fingers at people.
Yeah, which is strange because, I mean, we've been talking about triangles this entire time, and all of a sudden Bebby comes in with some completely unrelated thing about the definition of a flat earther.
Yeah,
What's that got to do with anything?
nothing.
Oh, just normal obsession.
Yeah. And he says, sorry, why bigotry? There is no shame in believing that a surface of equal potential on the Earth is planar. Why so embarrassed? You seem triggered, which was not my intention. Again, not triggered, but confused, really, let's say, understanding why the definition is. So I say, knowing that a water level is a tool for establishing a horizontal plane of reference does not assign anyone to any group. Your ability to link the two shows that your need for bigotry to dismiss an obvious fact of reality. He replies, knowing that a water level is a tool for establishing a horizontal plane of reference does not assign anyone to any group. Of course not, he says. The crucial question is whether a surface of equal potential on the Earth is planar. Do you know the answer to that question? And if so, what is your answer? P.S. I believe that you can establish a horizontal by means of a water level, but I do not believe that a surface of equipotential on the Earth is planar.
Okay, so he doesn't believe. That's okay. He's skeptic.
Yeah, but
Right.
what's he saying?
I mean, this is a contradiction. Like, I believe P and not P. And if you want to break it down, we can, because surface of equal potential actually has a meaning that is very much related to a horizontal condition if we really want to go there.
Yes, because horizontal is equal potential. So he's saying that, therefore, if he does not believe that surface of equal potential is straight, it means that horizontal is not straight. But he's saying this in two sentences.
Yeah, he seems to be saying that a water level, it's on his PS. I believe you can establish a horizontal by means of a water level. But I do not believe that a surface of equal potential on the Earth is planar. So he is saying that the horizontal plane established by the water level is not a surface of equal potential.
Yes.
Yeah.
Okay. So the water level isn't a surface of equal potential, which it makes it a little bit, what is a surface of equal potential then? That, that's it. Before you know whether an surface of equal potential is planar or not. You need to know what it is. But it appears that a surface of equal potential is not derived from the water level, right? By Beddy's own words.
Yes, because he has hidden presumption here.
But
He's not saying, but he has.
Yeah, you're trying to work out what that is.
This is curved level, of course.
But is that not a water level?
For Baby, it is not.
Well, okay. So, Stefan Mudd says, since you're online, care to explain the mathematical contradiction between planar and spherical triangles is? Like, we've already done that. Like, he's just one of these people that keeps it coming on. And it seems as if you want to invoke the law of non-contradiction as an argument regarding this.
I could do that.
Yeah. Yeah, you can't contradict yourself within mathematics or reality. It's just not done. I mean, I know that there are people that do, but not really.
There are some comedians that do. They get a good laugh.
I reply, triangles have 180 degrees. Anyone who wants to say that there are triangles that don't would be contradicting themselves, as triangles don't have more or less than 180 degrees. Beddy, would you say that an equal altitude is of equal potential regarding pressure and height? Would you say there's a chance that you're a diletheist if you can believe two truths about even and equal? I'll state that again, right? Asking Beddy, would you say that an equal altitude is of equal potential regarding pressure and height?
I would say that height, yes, because altitude and height, it is the same. But why pressure? Pressure can change, so.
But the equal potential is what I'm trying to narrow down. What is equal potential? What is the potential equal?
It is vague term, because potential, it is potency, ability to be in some way or more or less. This is what potential is.
Okay,
it
well,
can be.
The water level, right, has a potential of 0 regarding pressure at the level, right? You could go down, you would be increasing pressure. You could go up, you would be applying negative pressure. As above, so below, from each of the points of equal height. But that equal height is only relative to the other end of the water level, isn't it? Like, you know, like how do you tell the height? So in order for you to understand the height would be the equal potential, right? This end, that end. It's Beddy that's saying the potential. I'm trying to understand, what does he mean? Because how do I say if it's planar or not until I know what it is? I don't know what he's even talking about or how he talks about it.
This is his way of speaking.
Mm-hmm.
Confusing.
Yeah. Stefan Mudd says, no one is denying there are triangles having 180 degree internal angles. But there are triangles which have more than 180 degree internal angles, spherical triangles, as proven by mathematical theorems. So again, he says here, no one's denying that there are triangles with 180 degree internal angles. Then he says, but there are triangles which have more than 180 degrees. And no, there isn't.
He's saying that there are there are triangles which are not triangles.
It's, I mean, he's saying no one is denying the 180 degree internal angles of the triangle, And then the very next sentence he says that he himself is denying that there are triangles, or rather that triangles can have more,
Yeah.
which would deny that they have exactly 180, because these ones apparently have more. So that would be a direct contradiction. Only 180 and more than 180.
Yeah, I would say that this is the same situation as with curved and straight line, because you can say that straight line is curved line with zero curvature. The same with triangles. So that would be special triangle, and not special would be more or less. But the special would be 180 degrees, like straight line, for example. Only one, a special case of curved line. But it doesn't work, sorry.
Did you just say that there are some triangles that can have less than 180?
Yes, on this conical, let's say, surfaces. So
Could
they
you
are
go so far as to say that there are triangles with 0 degrees internal angles?
Yeah, so this guy, this Jacek Brodsky, like 1 year ago, we went through this mathematician from Southampton, I think. He was saying that.
I remember, that's when you gotta understand the ridiculousness of this whole thing, right?
Yeah, of course. But what I am saying is that they are trying to put this triangle, this Euclidean normal triangle, into spherical, let's say, geometry as special case. But it doesn't exist. It cannot exist.
Well, how can
Because,
you do that if you're dealing with spherical geometry, which is not Euclidean? I mean, a triangle is Euclidean, so wouldn't that be a stolen concept?
yeah, absolutely. Yeah.
Oh, I've got it. Equipotential lines are like contour lines on a map, which trace lines of equal altitude. So equal altitude, Betty.
Yes.
That's
There,
exactly what I was asking. Equal altitude. Yes. In that case, then, yes. A horizontal condition is what we call that. Yes.
And this is plane.
Yeah.
And this plane is parallel to plane of the horizon. Unfortunately.
and of course, perpendicular to any plumb bob you decide to hang.
Don't mention that.
Pretend I didn't say it.
Here we go. I'll put it in the chat so everyone can see. I'm pretty sure we went over this sort of stuff when we went over the contour lines, the equal altitude for when we were doing the transitive law of equality.
Yep, we did.
So yes, blue contour line, Betty, contour lines, horizontal slices through the map at an equal level. They're all the same vertical on they all have the same value on the z-axis, the same vertical height. Yes, Blue. Betty, sorry, I keep calling you Blue. I get mistaken. I know you are a blue marble scientist, but you are the standalone dogmatician, proofless dogmatician. Oh, sorry. Aporia proof. How is the aporia proof going down? Or proof of aporia that you handed to blue marble science. I hope
Did
that's
they
going
work
well.
it out?
Yeah.
I did. I know there are many paradoxes there, but I'm waiting till they resolve this bunch of paradoxes involved there.
I would like to see them try, but since I know they can't, I think they may have just accepted it as face value and just drop it. Don't talk about it. Never mention it again.
And then Betty says here, look, he says, I said nothing about altitude. Equal potential is the same as equal elevation, though.
So altitude is not elevation?
Well, elevation is of the land, altitude is above the land, but they're all both referenced to the same datum. Well, you can reference them to whatever datum you want, but overall they would both be referenced to the same datum. So
yes, vertical, yeah. I would say.
Yeah, but I mean, like, just because you're at 100-foot elevation,
yes, I understand,
doesn't mean that 100-foot altitude is on the land. Like, you could be at a low bit of land and at 100-foot altitude, but be at exactly the same level as 100-foot elevation.
Yes, and it has nothing to do with the shape of the Earth, I would say.
Well, but equipotential, right? As far as this is why I was trying to relate it to each end of the water level and the pressure of the water level. Right? It all depends on what your datum is. I can understand the different pressures. I don't know whether it works at elevation, height. I'd say so because it everything gets referenced to sea level, doesn't it? For when you say the boiling of a kettle or boiling of to 100 degrees of water, they say that it happens at a different elevation or altitude, or does it matter whether it's elevation or altitude? I don't think it does it?
Yeah,
no, that wouldn't matter. No.
Basically, I was just checking whether Betty's actually aware of the difference between altitude and elevation. I said nothing about altitude. Equal potential is the same as equal elevation, though. Then Stefan Mudd keeps coming in with these really weird questions. He says, one quick question, do spherical triangles exist? I think he's trying to get Betty off talking about this, trying to get us back to spherical triangles. And I say 3 circles on a ball can exist with the ball. Yes.
There you go.
Quick answer. And then Blue Marble comes in with a water level is a tool for establishing 2 points of equal elevation, altitude, I'd say. But that's different meanings, different people. Like, I mean, who's to say? Blue thinks the elevation of the water level is on the land, but that's different. Meaning following the curvature of the liquid parts of the Earth's surface. 2 points don't define a plane for you information. You need 3 points for that. You may not have picked up on that when you tried to study Euclid, says Blue Marble Science.
Yes, you can turn one end into different locations and you will have a third point. No problem.
Yeah, you can leave the center point, 1 point static and move around with the other one to many different points. So he doesn't really understand that, obviously.
If you take his sentences as standalone sentences, that a water level is a tool for establishing 2 points of equal elevation, meaning following the curvature of the liquid parts of the Earth's surface, like that's an actual true statement, even including the, empty truth. What's it called? Vacuous truth. and 2 points don't define a plane. You need 3 points for that. Like, yes, but if you don't take them in isolation, those 2 points are the points of a water level, which the two of you just went over that. So it's interesting the way he does his sophistry.
Yeah, a bit earlier on, somebody agreed that 2 points does establish a horizontal.
Right?
But Blue
Yes,
Marble seems to think that's following the curvature of the liquid parts of the Earth's surface.
but that would mean bendizontal.
No,
No,
there's just
that's why I'm
zero curvature.
yeah, like you stated earlier, Paper, it's a vacuous truth to put in the curvature of the liquid parts when it's 0.
Yeah, so it means the same as the straight line is curved with zero curvature.
Yeah.
So the same thing here.
Yeah,
A
it's
very
like
special
they're
kind of sophistry,
performing
yeah.
sophistry upon themselves
Yeah.
by just allowing them to imagine the adding the word curvature when there's a 0. It's the same as the 0 angle, isn't it? It doesn't actually exist, but because you've put a 0 angle, then I mean the angle is there within word form.
0. So you are bringing 0 to existence.
Yeah,
This
so
is
not
like we went through this Plato sophist. So step by step, bringing nothingness into existence.
Yeah, the making the that of which doesn't exist. Great. And then Blue seems to think that you need 3 points to establish a plane. Well, he said when we studied Euclid, we do have this test called the realizing Euclid test, and that's for the showing the straight line within a plane. And yes, we have more than 2 points, obviously. That's what's needed for proof. But for just establishing a horizontal plane, you only need 2 at water level. It does it. Like you don't. How many points are there with a spirit level?
I mean, how many points is there on a straight line?
It's weird, isn't it?
Mm-hmm.
We've got. I think I was talking to whoever it was. It said, "Would an equal elevation be parallel to equal altitude within your logical structure of reality? And would that be considered an equal potential, or do you mean something different than what I've explained?" I'm not sure that there's a contradictory proof within mathematics. Triangles have 180 degrees. I understand that there are other shapes you may want to call triangles, brackets, 3 circles, but they aren't triangles. There are no such thing as contradictory proofs within mathematics, but I guess your chief Blue Marble scientist will be demonstrating it in basic steps so everyone can see the 3 circles turning into a triangle soon enough. Do you know when, and will you be adding your expertise to help him? Replying to Stefan, obviously. Betty says, I am not talking about equal altitude, but equal potential. And strangely enough, when I looked it up, it said, like contour lines of equal altitude. Which is the same as equal elevation. What? I'm not talking about equal altitude, but equal potential, which is the same as equal elevation. Well, equal elevation is the same as equal altitude.
So he's saying that he is not talking about altitude, but he is talking about altitude.
Yeah, that's sophistry, right? I'm not talking about that which I am talking about.
I am talking about not that altitude.
Yeah. I have given no structure of reality. Literally, he's wrote that. I have given no structure of reality. I have simply defined a flat earther as one who believes that a surface of equal potential on the earth is planar. I don't know whether you are a flat earther under that definition, as you haven't answered the question as to whether you believe a surface of equal potential on the earth is planar. I certainly think you belong to a group of people who simply refuse to answer direct questions. So since we now know that an equal potential is an equal elevation, equal altitude, we can say that contour lines are horizontal slices through the elevation of the land to depict contour lines. So they are planar. Quite obviously, on maps, they're planar. That's what they are. They're contour lines. They're slices of an equal, horizontal slices through the land of an equal vertical height on the vertical datum. So according to that, people who make maps are flat earthers, according to Beddy. He's just redefined people who make maps into flat earthers. So well done, Beddy. I guess in order to label me as a flat earther. So thank you very much. And I'm sure everybody will thank you for that. Obviously means nothing, because nobody listens to a proofless dogmatician. And then I say to Blue, I say, you've not looked into the realizing Euclid tests, have you? Speaking from ignorance doesn't look good coming from the chief blue marble scientist. I'm sure you have many budding future blue marble scientists waiting on your every word. You should really think about what you say. I'm thinking about it now and thinking, who really listens to blue marble science for their scientific acumen? You know, like, where do they go to learn about blue marble science? I think I've been going over this, and I'm beginning to believe that us stating that, like, this is how surveying works, this is what it means in surveying, these are what contour lines, we've been over them many times before, this is what it is, and this is in reality, but it seems now that us saying that is causing the blue marble scientists to, I don't know, are they handing out their lessons of the not that? They're taking what we say as that, and they're just saying not that. And then they're trying to build up a scenario like Beddy's doing here. It's disgusting.
I think so. I've been on that page for a good while now.
Yeah. So these sort of things won't be going on for much longer, because I mean, I've had enough of it. They can do whatever they want to do with their not that, and we will be focusing on that, and mainly the mind tricks that go along with that. I know we've got mathematicians with us that like the idea of looking into puzzles and being able to explain the basic simple things of reality. So that's what we're going to be focusing more on, and obviously the conversations of how people derive this sort of stuff. I'm going to be explaining a lot more about how my particular mode of thinking has come from my upbringing, let's say, and I want to also check with other people, because there seems to be similarities and differences within thought processes, and that's where I'm, obviously it's try thinking, so that's what I'm here for, that sort of thing, and that's what's going to be happening. Yeah, we're going over that in midweek, so if you notice we're not around midweek, Tuesday, Wednesday, Thursday, pop into Discord, because that's where we will be. We'll be doing this sort of stuff on a more intimate level. It's always better when we do it like that. Get rid of the inquisitive not that, and focus on the that. I also say to Betty, I'm trying to understand what you call an equal potential. Do you believe that a water level is any different if it's on the ground or above the ground? And would you say that a water level is an equal potential if it's equalized whether it's on the ground or in the air? To which Betty says,
question.
Yeah, which Betty says, so you don't know the meaning of equipotential? I mean, I'm not asking for the meaning of equipotential. I'm asking for your meaning of equipotential, Betty. You're the one that's defining a flat earther around the term equipotential. It's only fair that we know your meaning of equipotential. You're the one defining this thing. I'm playing a game with you, Betty. You're defining something as though you're the dictionary man. It's only fair for you to go along with the terms of your definition. Crazy. He said, I thought you were an expert on the subject. Didn't you study surveying? It's a standard part of the course. Also, I covered the subject in my presentation of Aristotle's proof. Did you watch it? He's talking about the proof of aporia over at Blue Marble Scientific Channel. I did, but it didn't really stick in my mind. I was waiting to hear the Blue Marble scientist's opinion on what occurred, and then I'll go with that, Betty. That's what I'm saying. I was confused, but I'm guessing since it was a proof of aporia, the idea was to confuse the people watching, and it definitely did that for me. What about you, Blue? Anybody else?
Yeah, they were confused. That's why they went into Eratosthenes instead of.
Yeah, they'd rather debunk Aristophanes than even glance at Betty's proof of aporia.
Yeah. I would say that they think that would be maybe some kind of proof, and they cannot spot paradoxes there. But I will wait patiently. Maybe they will spot someday, maybe not.
Yeah,
I mean, if
we
somebody,
could go over it at some point.
I was gonna go into that saying, if somebody, brackets, any Blue Marble scientist, wants to come over and discuss Betty's proof, then that would be a reason to start talking about it. But I'm not so sure talking about it preemptively is gonna do anything for anyone.
Yeah. Or Betty could actually do a going over Betty's proof of aporia over at Blue Marble Scientist. They should give him the floor, because I think they rather rudely shut him out of the conversation. He just done a presentation over there, and they immediately shut him out and started talking about Aristophanes, which I thought was very rude. But Betty seemed to enjoy it. I think that's what he wanted.
Yeah,
maybe he realized that they don't understand what he was talking about. That's why maybe he talked also about Eratosthenes, because he realized that they didn't get it.
Yet a more reason to properly go over it.
Yeah.
I would say, I think he's hit on one of these things. ECV, as we've always talked about, the existential cognitive veiling, right? There's two forms that can trigger it. One of them is the reductio ad absurdum, which obviously is so absurd that the mind can't comprehend it. And the other one is the what do we call it? The argument that places somebody in aporia straight off. It's like a direct show of contradictory proofs or whatever. I mean, I don't know. It's the proof of the contradiction within the syllogism, and that triggers this. Call it cogdis if you want, but we call it ECV.
This is paradox. Paradox, in fact, is that state that you have something and you don't have at the same time. So this is this state of contradiction. For example, you know someone and you don't know at the same time. Or you have this measurement and other measurement at the same time. So this is paradoxal because you cannot have, for example, this measurement of the angle to a curved line. You have paradoxal situation that at the different distances you have different angles, but still it is same angle supposedly. So this is paradoxal situation because you cannot have one angle with 1,000 of different measurements. So it is contradiction because you cannot have multiple in one. So yes, I would say that paradox is always some kind of contradiction.
And that's what Beddy, I think that's what Beddy took over to the Blue Marble Scientists.
Yeah.
But I mean, I don't know. I'm not too sure. I'd rather hear from the Blue Marble Scientists, like, their opinion of it. I mean, it'd be unfair for us to give our opinion because that may help them with the not that.
Yes, I'm still waiting how they will deal with that, but I think they will not because they don't spot paradox. So, but they should because Baby said that this is aporia. So he brought them aporia, paradox, and they cannot resolve that. So
perhaps a little bit too hard. And you think it was a bit unfair of Betty to take them an aporema, right? Do you think it's?
I don't. Maybe he's just playing game. He's playing games with us, and he's playing games with them. Why not?
I'm not too sure what sort of games he's playing with us. I do commend him though for taking a proof of aporia over and demonstrating it in slides directly to the Blue Marble Scientist. I thought it's got to be some sort of a challenge. I think he and Mike Jones are working together, to be honest. I think Mike Jones would like to be able to have a conversation with the Blue Marble Scientist, but he can't. So he gets his friend Beddy to go and deliver the aporia to them.
Okay, but
it's good, isn't it? Yeah, it's like that's
they cannot
nearly as good as his aporia.
And they don't know that they are in aporia because they cannot resolve paradox. They cannot see paradoxes in his example. For them, it is just fine.
Well,
You know, I didn't take you as a conspiracy theorist, Bev, but I kind of like this one.
yeah. Well, I've said all along, right? There is a really sneaking suspicion that Mike Jones sounds just like Jesse Kozlowski. You know, like
Okay.
really like Jesse Kozlowski. So if you wanted to play games and hand the Blue Marble scientists aporia, I mean, on the theme of things, I think, you know, I mean, it would prove it, right? If the Blue Marble scientists weren't able to talk of this, then that would be mission successful as far as the delivery of aporia to the Blue Marble scientists. But hey, time will tell. We'll see where the Blue Marble scientists and their proofs lie.
Maybe they need more clicks for that.
Oh, he's doing all right for that. He's got a big enough following. He doesn't want to scare them with aporia proofs of aporia, and what else? Right. There has been many different clips, because there are other people that are putting out other things, and I'm testing out the waters with the argument around different places, and it seems to be going quite well. I like the idea of being able to present simple arguments that certain people can't rebut, and spherical geometry and all of that. But can I do you want to see
We got 6 glass.
let me just get this this is another one of the scientists, and he's got a lot of views, especially on one of them. Look at that.
High level 3K views.
It's done better than the others, hasn't it? Okay,
I'm gonna have to note the time here and come back to listen to this later because it's bedtime for me.
okie dokie.
So good night, everyone.
All right, catch you
Good night.
later.
Yep.
Okay, so this is a series of 3 videos. I take it this is the first one, second one, third one. Everyone all right with that? Does that look like the order you do them in? Eye level first. 5 minutes, 12 minutes, 6 minutes. 5-minute video about eye level. This is quite interesting. Remember, this is modern day science about eye level. This in turn has quite a lot of questions
Today I
about
want to
it.
discuss the curve of the horizon. I've come to realize that people can get a little impatient with topics like this. So I decided to put together.
Right, okay, here we go. Listen to what this modern scientist is doing.
Welcome to Icon Science Stat. Today I want to discuss the curve of the horizon. I've come to realize that people can get a little impatient with topics like this. So I decided to put together a playlist of short videos to review the topic and then introduce what I hope might be new material.
Let me just get that. Well, you can see that curvature of the horizon. It's fantastic. This we have the argument. The argument states if all horizontals, planes, lines are parallel to the plane of the horizon, then all horizontals will be parallel to each other, that being planes or lines. It doesn't really matter. But a corollary to that argument would be that the plane of the horizon is horizontal. Since that argument has never been rebutted, then it's of the understanding that the plane of the horizon is horizontal by just about everybody in reality. And
Yes, so this is just assumption. So talking about curvature of the horizon is just pure assumption.
well, this is modern science, right? So modern science is taking on the well-known and dictionary-defined horizontal horizon with modern science to attempt to derail that and place a curve to the horizontal horizon. Interesting take.
That should allow viewers to jump straight in where they are most interested, and then come back and review other videos only if they want additional context. Let's start off with the initial claim. And before anyone claims that I'm strawmanning the argument, I'll play the audio directly from Eric Dubay as he makes them.
The horizon always appears perfectly flat 360 degrees around the observer, regardless of altitude.
That's a ridiculous claim. Because it doesn't. The horizon doesn't always appear perfectly flat 360 degrees around the observer, regardless of altitude. Ridiculous claim. Number one that this scientist is using to rebut.
The horizon always rises to the eye level of the observer as altitude is gained.
Ridiculous claim numero two, stated by this modern scientist.
Yes, horizon is not rising, is just staying where it was. So as you are gaining altitude, the horizon stays at the same level it was. That would be correct. It's not rising.
Okay, so they're the first two. He's trying to do a curvature of the horizon, and he's going to rebut two ridiculous claims made by some ridiculous person who has said some ridiculous things. Science, modern science, this.
So that's what Eric Dubay says, but is he correct?
No.
No, this is bad phrasing. I would say that I know what he meant, but this is bad wording. So incorrect, formally incorrect.
Blue Marble thinks Eric Dubay belongs to us. No, Blue. Not at all.
In this series, I plan to investigate these two claims separately.
So he's doing a series to investigate two ridiculous claims.
After that, I will attempt to explain how these two separate claims are actually tied together.
Both being ridiculous, said by the same person. To both being similarly ridiculous claims said by the same person.
For simplicity's sake, I prefer to investigate these claims in the reverse order. First, the horizon always rises to eye level as altitude is gained. Flat earthers are anything but unified on this issue.
I don't know why anybody would say flat earthers a thing. It's a ridiculous claim, right? But
Yeah.
again, introduction of a group of people that I don't know.
And by the way, he is talking about our vision. So this is what we see, and what we see is as we are gaining altitude, that horizon stays where it was in vision. This is he stays at the same level. Yes, at the same level. So this is simple description, and it is not rising.
You are rising.
Yes, I am
if your
rising.
altitude is gaining, if you are
Yes.
gaining altitude, then
Yes.
you are rising. The horizon stays exactly where it is.
Yes, but when we are talking about me rising, this is not visual. This is actual. Let's say you can measure it.
Yeah.
But this staying horizon that stays in your picture, in your vision, in your eyes at the same level, this is visual. So there is no link. You cannot measure it with centimeters or inches or whatever. You can measure your altitude with centimeters and inches, but this vision you cannot.
Yeah, you can measure a gain in altitude, right? So that's what we're saying. That as you gain in altitude, which can be measured as a vertical height above the surface or some sort of datum, but it's measured on a vertical datum, that altitude. We will get round to the eye level part, because I think that's one of the most important, one of the best questions involved in this.
Some, like Dubé, say it's true, and this is because the Earth is flat. They'll say this is how they know it's flat. Others say that the claim is...
So, again, he's talking now. This is the way that modern science is done with the guy. His channel's called I Can Science That. So he's sciencing that, the that being the horizon. This guy's sciencing, right? Now he's talking about what some flat earthers say. I'm not too sure whether this is a proper scientific method as to going and asking what flat earthers say. I'd say not. And basing your entire scientific method around some comments said by some guy perhaps isn't one of the best observations to start the scientific method about. I saw some guy say something.
Yeah.
Not really good, but I mean,
is false, that the horizon actually drops below eye level. This group would suggest that the drop of the horizon is due to an optical effect and does not indicate any curvature of the Earth itself. Second, we'll consider the apparent straightness or curvature of the horizon. Once again, some insist that this is true, and this proves that the Earth must be flat.
I would say that there is no proof that the Earth is flat. Just for anybody's idea here, and saying that something happens, therefore that's proof, doesn't constitute a proof. And surely some scientist should know that.
This is non sequitur because, of course, horizon is straight, and this is visual condition, of course. So it is visually straight, and it doesn't prove that the Earth is flat.
Non sequitur, as we say.
Yeah.
But hey, this is modern science we're dealing with here now. So we have to take in non sequitur things into consideration. Modern science. Who knows?
While others acknowledge that we do see a curve, arguing that this does not in any way indicate an actual curve. There are different opinions on these topics, but ultimately what has inspired me to make this series is a particular combination that seems to be fairly common. Some people agree that the horizon definitely drops, but argue that the horizon still does not curve.
Who says the horizon drops with altitude? I mean, like, what does that mean?
No, he's referring to his model, because this is what model, his globe dictates that it should. They say so. Glober would say that it should. So there is back and forth between flat earthers and globe earthers that.
Okay, I get that, but what does he mean by drops with altitude? Right? Because if you're gaining altitude, you're going up. But
Yeah.
the horizon is getting further below you because of your rising.
So now they are turning this into vision. So optically, it should drop, they say.
But actually, physically, you're gaining in height.
Yeah.
It's not dropping. Now, would you be able to use that as a scientific thing? If you're sciencing something, do you not think it would be better to say the horizon drops? It doesn't. The horizon just stays exactly where the horizon is. You can either raise, lower, sit on the floor, lie on the ground, turn around. You can do all sorts of different things, but whatever you do will not affect the horizon.
Yeah, but the argument is that on the globe, the globus, sphere, it should. And this is a very, very old argument from the beginning of this, let's say, back and forth between flat earthers and not flat earthers.
Okay, but then he says, but the horizon always appears perfectly flat. Does he mean horizontal?
Maybe, but he's not talking about eye level.
But the horizon doesn't appear flat. I don't think it ever does. Or do people have a different understanding of what flat is? Because scientifically, this is a guy who's sciencing it. He's sciencing the horizon and saying what other people make with claims. I mean, look at how many claims there are on that page there.
For me, this is false dichotomy, because he is saying the horizon drops with altitude, but the horizon always appears perfectly flat. This is false dichotomy, because there are two separate claims here. That horizon drops with altitude. This is one issue. And the shape of horizon, is it straight line? I would say he's talking, I think, about straight line. But I don't know why he's talking about flatness of horizon, because straight line is just straight line. Not flat, not flat. I don't know. This is false dichotomy.
He's got 6 flats on one page. So he might just like writing flat.
Yes, maybe he's
It's definitely not a scientific term, is it? Flat.
No, absolutely
it's
not.
Too vague for scientific or mathematics. So, again, the guy's called I Can Science That, and this doesn't seem like science at the minute. Anyway, you might pull it back. We are halfway into it. And he's telling us about a series of videos. I'd say since we've been over sophistry last week, this is building upon it. This is science sophistry. Sophistry within science. Modern science.
As we investigate the two claims separately, I hope to address this combination in particular. So, does the horizon rise to eye level?
No.
How can we test the claim? It's actually fairly easy and has been done to death. But here are a few different suggestions. Install an app on your phone. If you have an Android phone like me, Dioptra is available for free. On an iPhone, Theodolite is $8.99. If you don't trust the electronics, you can build a portable water level with $10 worth of parts available at any hardware store.
That's good. I'll show you that in a minute.
Just get up high and use your chosen tool to measure the angle down towards the horizon. You could go to the top of a tall building, or the next time you fly in an airplane. Or use this as an excuse to take a hike up a mountain. I always try to encourage people to go and test this for themselves, but I have had many requests to see my results. Have I actually done this? Okay, here you go. These are the photos I've taken myself. I took a trip to St. Louis and went up into the arch. I used dioptra to take a picture and showed the horizon below eye level. Since I have...
So there's the horizon below eye level. Yeah. Okay.
Below eye level? I don't know. Below, it is below this horizontal line across.
It's below that line
screen.
there, at least, yeah. If that's what he wants to call eye level, is the horizontal line, the straight line from going across the page, then, I mean, science, modern science.
I have diopter on my phone. I always try to check the horizon whenever I get a window seat on an airplane. Here's my homemade water level up on Mount Wilson.
Look at that. That's a Bob design, that. You know, the first time I ever met this guy or ever sort of heard this guy, I'll show you the clip of him in a minute. I'll get that ready for you. But yeah, this design here is a Bob the Science Guy designed water level.
Great stuff.
It's nice, isn't it?
But it is not aligned with this horizon or whatever, because you can go with camera higher or lower and this position would change. So I don't know what he's trying to prove with that kind of pictures.
It's a dark shark. We said that the idea of the local level is depicted local to where the water level is. So the level is relative only between those 2 points. It doesn't extend. There is a water level is not a sighting tool. It doesn't depict level in the distance. So what exactly he's doing is a bit like paper. I haven't got a clue. It means nothing.
Yeah, completely nothing.
The water is at eye level here, and the horizon is down there. Finally, here's a shot from the top of Sandstone Peak, looking out over the Pacific Ocean. I especially like this one because the sun is completely below eye level. I've tested this over and over, and every time I check it, I find the horizon somewhere below eye level. So the original claim, as stated, was false. But you don't have to take my word for it. Check it for yourself. Post down below in the comments if you've ever tested the horizon rising to eye level. YouTube is iffy about links, but if you email me your links or send me your photos directly, either through email or through Discord, I can paste them into a pinned comment here, and if I get enough, I'll collect them all together into a special video just for you all.
Right, so he's looking for these well, I don't know. Right, so do you want to see the thing? I've got to put a clip in the Discord. You might, I don't know whether you're going to hear it or not, so I'm going to play it now.
Get your Theodolite app and point it out the window and see. Another one. Let me see. I don't know if you can see me here. I made this. This is based on a design from Bob the Science Guy. I iterated on it, but I came back to his original design is brilliant. This is great. This cost under $10. So I just went to the hardware store and I bought some plastic tube and 2 of these little T-junctions and just make this shape. And then you put water in it and maybe some food coloring if you want. Just water is good enough. And what this is a water level. So you just put the water at a point in the tube on both sides. And then when you line these up so that the water lines are straight, you can see exactly what is horizontal based on that. Remember, water always finds its level, right? So the two water levels on the two arms of the pipe will be at exactly the same horizontal level. So you line those up, and that gives you a perfect horizontal. So then just point that at the distant horizon and answer. Did the horizon rise to eye level or not? Cost you $10. Anyone can do it. So,
okay, anyone can do it, and a water level is a device that tells you what is exactly horizontal.
Yeah.
Okay. So the plane of the horizon would be exactly horizontal.
It has to be.
Yet he's doing a series about the curve of the horizon. Seems very strange, doesn't it? How somebody who can believe that a water level is a device for establishing what is exactly horizontal. And then just to go with that, we've got this extra one when that comes, just to point out. All right, I'm going to play this one now.
if water forms a perfect plane, there can be no globe. You cannot have a globe. You cannot have a globe if water forms a plane. You cannot have a globe. I think everybody can agree with that.
Whoa, that's good.
See you later.
You cannot have a globe if water forms a plane.
Mm-hmm.
Thank you.
And if science tells us that the ocean is a globe, science cannot tell us water forms a plane. You cannot have a globe.
Science.
If a water level is a tool that establishes a horizontal plane, poof goes the globe.
Sorry.
Yep. So, if water forms a plane, like a horizontal, a perfectly, exactly horizontal, then there can be no globe. And this is the guy, perhaps this is one of the reasons that he wants to curve the horizon. I'm just saying. Who knows?
But he would be in contradiction with himself.
They like contradictions, don't they?
Yes, they do. They do.
Right. There we go. Right. So in the question, right. So this is a video. He's titled eye level, and he's sciencing that. He can science that, and this particular video is eye level. Now this guy, modern day scientist, is sciencing eye level. Now here's the question. A lot of people have fallen into a little bit of cog dis surrounding this very question. I ask, is eye level a straight line to you? Pretty simple question. There are 79 replies. So this is one of the questions that I've been asking people. Now, does anybody want to offer up beforehand what they would think eye level is? As always, my questions may be leading a bit, but that's up to people to see through the being led through the question. Really, the question should be, what is eye level to you? But by leading them a bit, is eye level a straight line to you?
For me, eye level is straight line because any level is straight. So it doesn't matter if it is eye or not eye, but if it is level, it is straight.
Right. Well, here's the thing. I think, personally, when people do this, and I don't want to give it away because there's only 20 odd people watching. So when you ask people what is eye level, they are two words that are not connected in any way whatsoever. There's no definition of this eye level. Like Paper said, level is one thing and your eye is something different. So what they are asking really is, how do you relate your eye to level? And I'd say it's just the vertical height of your eye. Level is what can be established from that particular point of the height of your eye. But as we've had a discussion with mathematicians and all of that, the question, the eye, is just a vertical height. From that point onwards, you would need a tool to derive level, as your eye is not a tool for deriving level. They're just two completely unrelated things. So in saying eye level, what you're actually saying is, how do you relate your eye to level? You're not saying what is level, are you?
No, by saying eye level, for me, Kevin explained that, how he understands that. And I will go with that, because it has nothing to do with geometry or surveying. So this is just popular term, vague and not precise. So, but basically it means that you don't need to tilt your head or eye to look down or up to look at the horizon. And the horizon would stay at the same position in your eye, let's say. So so you don't need to move your eye higher or lower. You don't need to turn your eyes as you are gaining or losing altitude. This is just so it stays at the same let's say level in your picture. This is what it means, but it doesn't say anything about your altitude.
Yeah, he's drawn a horizontal line in his theodolite app or whatever. That is just a horizontal line. And I think he's relating eye level to that horizontal line. That's why I was asking, is eye level a straight line to you? Because it seemed like he was relating eye level to that black line that went across his theodolite app. In which term, it's just a horizontal.
Yeah. Basically, yeah.
And then there's a lot of, obviously, people saying, this guy says, nope. Eye level is an imaginary, infinite, flat plane. I don't know why flat to plane. A plane, horizontal, equals perpendicular to the vertical at the height of your eye. It is, or for this individual, e.g. camera, can have an eye level. So cameras have eye levels as well. And specific for that location. There is a thinkable concept of, e.g. an infinite flat plane. I don't know why people keep using that flat plane. Like, tell me you're not obsessed without telling me you're not obsessed. Flat plane, does it not mean it exists? What? E.g. an infinite flat plane does not mean it exists. Like, we can think of a convergent point that is on the viewing axis, brackets, as most lenses are round in infinity. The trouble is that this group of people is that they simply assume that all verticals are parallel and never verify that, simply assume it as truth. And remember, like, questionary is level a straight line? And look at this. Again, this group of people, whenever they say that, people measure eye levels of opposing shores on lakes several meters apart, same level of reference of water over the lake on parallel verticals. They just go on about all sorts of stuff when the simple question, I was hoping for an answer of from the guy that actually made the video, but strangely enough, he goes around liking all of these comments, but not really answering. I say, do you imagine that eye level is different than the parallel level lower? And again, this guy, look at this. This is where it gets really weird. He says, you sure do try hard to defend flat earthers for someone that isn't a flat earther. I mean, I just asked the question, is eye level straight? I mean, is that defending flat earthers? And is that all it needs, is to question this scientific method? Are you then defending flat earthers by questioning modern science? Very strange.
And Strawman, because he's not answering question.
Do I reply to him? This isn't a flat earth issue. This is science. Shouldn't we define the subject of scientific inquiry? This guy says, dodge, duck, dip, dive, and dodge, latching onto a specific word to avoid answering a question. I asked the question. So...
Yes, but
I haven't got a clue what they, like, they don't even know what they're saying. An answer for once. Eye level is the center line of the viewer's eyes. Like, what does that even mean? What's the center line of your eyes? That doesn't, it's a vacuous statement.
You can point your eyes, where, for example, up in vertical position. So yeah. It doesn't mean that it is at level. So just nonsense.
Yeah. The horizon never rises to it, obviously. I live at the coast, 100 foot chart datum. We always look down to the sea. Yeah, brilliant. Somebody else doesn't understand eye level or sea level, says the guy that says it's just the center of your eyes. Dog Walker says, hey, have you ever tried thinking, or do you just chant flat earth mantra? Asking people whether they consider eye level to be a straight line is now apparently a flat earth mantra. It gets worse and worse, really. I said this isn't a flat earth issue, this is science, brackets. He's quoted me. Thanks for admitting that flat earth and science are polar opposites. Again, I don't know. Somebody says, so if eye level is not a straight line, then does the horizon always rise to the eye level of the observer?
No, so not answering that question.
Yep.
He's answering a different question. I would say that you will find nobody answering this question, I think.
Question is nonsensical. Eye level with / to what? There is no horizon on a flat plane and no formula for calculating distance to the horizon on a flat plane. The point, if you have seen the horizon from any elevation, you have personally witnessed the curve of Earth. The question is nonsensical. The is eye level a straight line to you? Nonsensical. I ask, so can you answer the question? Is eye level a straight line? He's telling the guy that said the question is nonsensical. This is Stefan Mudd saying, you already gave a good answer regarding this. That's eye level is an imaginary infinite flat plane horizontal. I don't know how your eye does that. The horizon doesn't rise. This is me. The horizon doesn't rise because the plane of the horizon is horizontal, and horizontal doesn't rise or fall as it has zero slope. Also, the Earth is not flat. When performing science on the horizon, would you say if eye level was straight or not? So then you disagree with all of Flirts, who suggest the horizon rises to eye level. Obviously, yes. So now we've removed your inclusion of the ridiculous. Can you answer the question, is eye level a straight line? Me, again, having to ask. Stefan Mudd says, how can you claim the Earth is not flat, at the same time claim all horizontals are parallel? What must the conclusion be if all horizontals are parallel to one another? That all horizontals are parallel to one another. That is the conclusion. What must be the conclusion if all horizontals are parallel to each other? No, that is the conclusion to the argument.
Yes. Based on that this is plane of the horizon.
If all horizontals are parallel to the plane of the horizon. Pretty simple statement, isn't it?
Yeah.
I say reality is the conclusion. As long as we keep to reality, we can prove the real globe to be reality. That's me stating that to him. I always have and always will be, because the Earth is not flat and horizontals don't rise. Again, me stating that. Me again. It never was to begin with. You can forget about it and go on your daily life without worrying about flat Earth, because it's not real. Only reality is real. Perfect. I just wondered if your discourse here that you agree that the horizon would never rise to eye level, and that should be expected. Also, you almost assuredly have claimed that the Earth is flat a long time ago. No, it's not flat. It's ridiculous. Yes, reality is the conclusion. Your problem is that your claim does not in any way, shape or form conform to reality. Sorry, paper call.
No, just another people that want you to be a flat earther for some reason.
I put yes, reality is the conclusion. Oh no, he put that. I put the Earth is not flat. It never has been, never will be. Now, do you think you could answer the question, is eye level a straight line, or is this too much for your scientific curiosity to comprehend? Stefan Mudd. Is your excuse for claiming to not be a flat earther because Earth having a topographical plane, waves and tides? TJ Jones said, I already did. Eye level is the level that your eye is at. There is no line. You are talking about line of sight, dude. Now, your map, the name, quit stalling. From nowhere again. Are you really asking if we can see around a curve? Lol. I say so. It's a point on a vertical datum then. Do you think that's what everyone else imagines also? No, light travels in straight lines as far as I know. No curve. My question, have you answered? Is eye level a straight line? Curios says, correct. The earth is not flat. Glad you finally agree with the rest of us. As for eye level curving or not, give me more details. How much refraction are we dealing with? Are we talking about 100 foot always being 100 foot? Regarding scientific inquiry, you're giving us little context. Remember, this video is on this channel. This channel is called I Can Science That. We're inquiring as to eye level and how this channel that we're dealing with here sciences eye level. Stefan would actually. This guy here says vertical datum. Did you just make that up? Lol. I think that everyone uses the exact same map of the earth you use to drive around. Is this why you don't want me to know the name of yours? You nailed it. As far as you know, it's not very far at all. Light can't bend. You're really trying to convince me of that. I want to know the name of the map of Earth you use to navigate Earth. Quit stalling and try typing, try thinking. This is TJ Jones, by the way. TJ Jones. You're not representing this channel very well if you don't know what the vertical datum is in reference to your eye level. Can you imagine how a point on a vertical datum can tell you anything about an imaginary point in the distance with modern science terminology? He says, you are not representing reality in any sense. I repeat, it does not matter the height of the observer. The distance to the horizon at any height is calculated by a curvature formula. There is no such formula for calculating distance to the horizon on a flat plane, because there is no horizon on a flat plane. You are trying to ignore the reason you even see a horizon in the first place, and you are failing miserably. What's everyone think about that?
No, he's referring to a visual horizon and curved horizon, like topographical. I would say that this is topographical horizon because due to curvature, that would, for me, that would be topographical. They say that would be geometrical horizon even, which doesn't make any sense for me. I would say that that would be topographical horizon, but if it is not curved, this is just optical. So for me, it is a plane of the horizon, and that's why it is visual only, not geometrical or topographical or whatever.
Yeah, he's got the distance to the horizon at any height, he put that in big letters, is calculated by a curvature formula.
Yes, only on that globe model, globe model.
He said there is no such formula for calculating distance to the horizon on a flat plane. Because there is no horizon on a flat plane. There's no such thing as a flat plane.
Yes, of course, not flat plane, but there is plane of the horizon, and of course,
reality, yeah.
And you shouldn't use this formula, this curvature formula, because why? But he's not right.
Formula?
No, it is not. Yeah, so I don't know any formula for horizon, but he is not right because he's saying because there is no horizon on a flat plane. Maybe, but the plane of the horizon ends off this line, and this is called horizon. So he's not right. Okay. He's just.
So can we say that, though, by a quick little bit of deductive logic, that there is a horizon.
Yeah, of
Okay,
course.
so what we can do by saying that is that we can just completely disregard the flat plane. Although I don't
Absolutely.
know how this guy knows that there is no horizon on a flat plane. But since there is a horizon, it would be irrelevant to speak of something of which you're going to say that that exists, but not on this. So why is he mentioning the flat plane? I mean, that
I have no
seems
idea.
irrelevant to me completely.
Yeah, yeah.
And it would show model affliction, right? If somebody wanted to keep bringing up something and then saying that it's not that, like that he's developing a not that so he can say not that. It's ridiculous. I hear you're no longer a flat earther, yeah. Remember, these are all answers and replies to the question, is level a straight line? On a science channel. I say no light travels in straight lines as far as I know. And they say, prove it only travels in a straight line. Haven't they? Isn't there many proofs that say that parallel straight lines, light, within their framework of their model? Or I don't know, like irrelevant to the claims that they're talking about and my question. They're picking up on other questions.
Yeah, this is their method because they claim that this is this terrestrial refraction, and this is 7/6R, Mick-West refraction, and it is just circular reasoning because still with that refraction you still see things in straight line, so you cannot detect refraction, you still see in straight lines, so you cannot prove that they are not straight because of refraction, because you don't see refraction.
Oh, here he is. This is a reply from I Can Science That. Is the first reply from him to the question, right? Is eye level a straight line to you? And his reply is, we have a specific rule against lying here on the channel. When you state I've never been a flat earther, having proof of the earth is not flat means I know the earth is not flat. That's what I said. That appears to be a lie, he says. You have quoted referring to flat earth, and those quotes are still available. I'm quite serious about this. I give you this opportunity to correct this misunderstanding. Now, remember, I don't know how many times I've said I'm not a flat earther. Pretty obviously, I'm not a flat earther. I've got a proof that it isn't a flat earth. Yet, instead of answering the very simple question, I Can Science That, the channel owner, made a video about eye level. He's not answered it. There's still no reply. He isn't stating whether eye level's a straight line or not.
Yes, he's going into this flat earth something topic, nonsensical.
I say, the earth is not flat. It never has been and never will be. This is not a lie. Everyone knows the earth is not flat. Stefan Mudd, on a surface with verticals and then I ask, I Can Science That again. Is eye level a straight line to you? Is eye level a straight line to you? Is eye level a straight line to you? If not, then that means level doesn't need to be a straight line. If it is, then the images in the video show the horizon does not rise to eye level. Either way, this is quite the quandary. So here's the next reply from I Can Science That. He says, "You're treading a fine line here. We don't allow lying. Please make the correction immediately. In good faith, here is a straight answer to your direct question. I will answer you, and I expect you to make corrections for your apparent lies straight away. Is eye level a straight line to you? When I use the term eye level, I am referring to the horizontal plane passing through the observer's eyes, or more likely camera. And in this case, the horizontal plane is the plane perpendicular to vertical at the observer's location. You have often suggested that you think verticals are parallel. I've not. I say horizontals. All horizontals are parallel. I don't deal with vertical. I know vertical is perpendicular to horizontal. In this case, the horizontal plane is the plane perpendicular to the vertical at the observer's location. You have often suggested that you think verticals are parallel, but you are perfectly aware that that is disputed. Whether all verticals are parallel or not, the definitions I have given for eye level and the horizontal plane should work just fine either way. You may have noticed that I'm using eye level to refer to a plane, brackets flat. A plane, brackets flat. Crazy.
Maybe he imagines that there is only not flat plane.
Yeah, there's different planes. But I also use the term level to refer to the equipotential surface, which I suggest is more like a sphere. That is correct. The English language does have interesting quirks, especially when we use terms in peculiar or colloquial ways. Eye level, as I'm using the term, is a plane, not a line. So he put it as a plane. I was just curious as to whether it was the line he had in his camera. So it took a while, right? So to I Can Science That eye level is a horizontal plane. I say, okay. I say eye level to me is a vertical height on a datum. For it to be the plane you speak of, in my mind, a tool is needed to establish that plane. Your eye or camera does not have that ability to establish a plane of reference. Again, these facts are established in reality, and the proof that the earth is not flat will come from our understanding of these facts. Everyone knows that the earth is not flat. Everyone knows that level is horizontal, and plumb is perpendicular to level. Level is a practical tool and practically horizontal with zero slope. I think we can agree on these basic facts of reality to be true. Please don't misrepresent me or my arguments as something I can prove false. I Can Science That says, it's now time for you to correct the apparent lies. You are quoted as having said the earth was flat, but now you claim you never said that. It seems clear that the latter statement is untrue, thus a lie. You have no correction to offer. I'm just going to have to label you a liar. Lying is not welcome here on this channel.
Okay, so he's just dishonest, blatantly, because he's talking about apparent lies. So and he didn't quote, because you are quoted as having said that. So yeah. He didn't bring any quotation from you. He's talking about some apparent lies, maybe apparent to him only, and he didn't say how they appear to be a lie. But this is enough for him to label you a liar. So this is just labeling people. For me, that would be already a slandering.
I reply, everyone can see that I can prove the Earth is not flat, and that I can prove you're abusing modern science with fallacious claims and ridiculous conclusions. You should be ashamed of yourself, but it's quite obvious you're delusional. I won't allow you to misrepresent science in this way. Are you scared your modern science can't uphold its truth value under scrutiny from someone who holds proofs within reality? The Earth is not flat and I can prove it. Rebut that claim and don't mention my statements contrary from a different source. Try to make me a liar on these claims I make to you. Obviously, no more replies. Whoever this guy is says, you must really hate BMS for calling you out on your FE beliefs. No, I don't hate anybody, and I have no FE beliefs. That's ridiculous. To think that somebody... Why would somebody bring that up? I mean, it's crazy. They're just trying to cause division, and it's not needed. Not with any of this. Again, TJ Jones, go. Right, so see what any of the other ones are. FE peer review. That was a beautiful sequence of images. I encourage any flat earther to do their own research and take a similar set of pictures. I mean, why flat earthers? Is this guy science? I can science that. Directing his videos at flat earthers. Are these like a science for flat earthers? Because I wouldn't suggest that this is any sort of science to be anybody to be thinking of.
Yes, and by the way, I never, for example, I never claimed that horizon is at this eye level. It is always below. So, but he is shooting this argument maybe against flat earthers who think that horizon is at your eye level, so you don't need to tilt. And of course, this is not true, because this horizon is always below horizontal. If you establish horizontal, horizon would be, I would say, this water horizon would be always below. Never, it will never touch this horizontal line. And the gap between horizontal and so middle crosshair and water horizon or true horizon would be bigger if you use magnification. So that's let's say argument that it is not on the same level because you are using magnification and the gap is bigger. The bigger magnification, the bigger gap between horizontal crosshair and true horizon. I would never use that as argument, but they use that. For me, this is just strange.
This is our friend Flat Earth Math. He's gone over there, willing to lend his help to modern science. He says, the horizon curve is a very, very tough puzzle. and I tried and failed to get some equations going on it. Equations on the horizon. The problem is there's no standard for visible curvature in our field of view. Let me look up what I did in an old debate with Jibby Jedi, R.I.P., where I described the distinction between the effects of curvature, brackets obstruction, versus visible curved horizon. I'll get back to you. It's a good job somebody's out there doing, what's he looking for? Some equations. You need some equations on the horizon.
Yeah. This is fascinating. For example, I am not interested.
Well, can you imagine equations on the horizon? That's fantastic.
Yeah.
An apparent position, location, the meeting of the ground and the sky. I mean, I'd say just about the only thing that can be said of it is that it is horizontal. Other than that, there's not much you can say about the horizon, to be honest. Over there, I suppose. I can science that. Says I was inspired by the other red water level you've seen before. It's there right on my board. Always left hand side of the whiteboard, right hand side of the whiteboard. Having seen many of these before, I felt that red gave the best contrast against the blue sky and ocean. Fair enough.
Okay, time for me to bed.
Yeah,
So,
I think it's time for
night.
me to end this as well. Tomorrow paper, we're going to be going over some more Plato stuff. So we won't be live. It'll be
no problem.
Okay.
No problem. I will be happy to be here tomorrow.
Yeah.
Good night.
Okay. See you later. I will be ending this now. Like I said just before, we will be midweek, Tuesday, Wednesday, Thursday. We will be doing the same thing as we did last week. It will be live. Well, we will be on Discord. So all of the time, always, as always, during the day, we do conversations. We do all sorts of things during the day. So come on into the Discord. We have much more freedom. Like last week, we went over many things, and we will be going over the rest of these videos and some other things that we have. Conversations with mathematicians, like I said. Some interesting times. We will be coming back again Friday for Free for All Friday. So thanks for watching. Let me queue up a Buster song. Anyone here for a Buster? What have we got? We've not had a. Let's have a Who Will. Okay. Buster. I think this is Buster and Shane. Thanks for watching. Join us again on Friday, or please do come into Discord and come and get involved in it. It'll be just a conversation, just chatting with people. We do go over many things, and we will be going over even more. We're doing an interesting thing with Plato, but we're hoping to develop something. So if you want to come in and get involved in it, if you like reading, if you think you've got a good voice, come on in, join in. See you Friday.
Yeah, it's an honor. Yeah.
Ramblings of these madmen going insane. And now I see it clear. They're running and they're hiding because of fear. If I never communicate with logical, if I don't sing, if I don't speak out, if I never receive the Logos word. Transcendental numbers and conceptual maths will take you on a journey down a Penrose path, and you'll never see it clear. The path that you're on will be ends in tears. If I don't sing and if I don't speak out, if I never communicate with logic or will, if I don't sing and if I don't speak out, if I never receive the Logos or will. Cast away the shadows and step into light, taking down giants and opening sight. And now I see it clear, the path that you're